So here in number one, so the first thing we have to know is that let's write the first quadratic equation that I have. What was the quadratic equation I gave you? Number one. 3x squared minus what? 2x plus 4 equals to 0. So here let's find my a. A is equals to 3, right? B is equals to minus 2. C is equals to what? 4. The next thing for me to do is what? Find my what? Discriminant. So how do I get my discriminant? D is equals to what? B squared minus what? 4ac. So what is my b here? Minus 2 squared minus 4, 3 multiplied by what? 4. Are we together? For me, I have minus 2 squared, which will give me what? 4 minus 4 times 3 is what? 9. That thing is 12. 12 times 4 is what? 48. And you know that here, d is equals to 4 minus 48 is what? Minus 44. And minus 44 is equals to what? Lesser than 0. Are we getting it? So that since this answer is lesser than 0, that means the nature here is what? Imaginary. Are we getting it? Now question 2. What's question 2? Minus 28x plus 49 equals to 0. What's your a here? Your a is 4. Your b is what? Minus 28. Your c is what? 49. Are we together? And from here, let's find your d. Your d is what? Minus 28 squared minus what? 4 bracket 4 times what? 49. Minus 28 squared is what? 500 and it's not 576. That's 27 is 729. That's 784. Minus, I think this one too should give me 74. Abi now? 784. If both of them 76, I can say that my d here is equals to what? 0. Because of d equals to 0, what is this one here? Equal roots. How we getting this, please? How we getting this, please? Now, the last one is what? X squared equals to x, x minus 5. So bringing both of them to the other side, so you have x squared minus x minus 5 equals to what? 0. So from here, okay, plus 5, sorry. What do I have here? So I can say that my a is equals 1, b is equals to what? Minus 1, c is equals to what? 5. So what's your discriminant here? Your discriminant here is equals to what? That is minus 1 all squared minus 1 over bracket what? 5. So what do I have here? 1 minus 5, which is, so d is equals to what? Minus 4, right? I mean now, because this equals minus 4, this one here is what? It's imaginary. I'll get what I'm trying to say, please. So good. B squared. And okay, let's stay 4 here. Yeah, that means I just okay. Even if there was a 4 here, it should have become what? 20, and it should have become what? 19. I'm getting that. That would be that about that for what? For nature of root. Now, next one I want to look at now. It's not a subtopic. We can let's call it miscellaneous question. Miscellaneous questions. Are we ready? So miscellaneous questions. Question number 1. What do you mean? What do you understand by miscellaneous? Miscellaneous means different kinds, combination, mixture. That's another word for what? Miscellaneous. Are we together? Okay, good. So from here, question number 1 says that if the equation, let's start. Number 1 says that if the equation if the equation out there x cubed minus 3x plus 1, if the equation x cubed minus 3x plus 1, I'll get what I'm trying to say like that, equals to p open bracket x minus 1 has equal roots, question says you should do what? Find the possible values of p. Out there. Let's go to question number 1. X squared minus 3x plus 1 equals to what? Px minus 3. Are we together? So here you can have x squared minus 3x plus 1 all together minus px, now minus what? 3p equals to what? 0. So if I collect like terms together here, what would I have? X squared minus what? 3x minus px plus 1 minus 3p equals to x, equals to 0. Then here you can have x squared minus x, now, which is 3 plus what? P plus 1 minus 3p equals to what? 0. Are we together? So from here, okay, it should be plus here, plus here, plus here. Is that all? So from here, let's get my a. What is my a here? My a is 1. What is my b in this case? Minus 3 plus p. Yes or no? And your c is what? 1 plus what? 3p. Okay, good. Alright, now the question says something. And what the question says that I should find the value of p that makes the equation have what? Equal root. Yes or no? Yes, so according to our condition, what condition can give me equal root? I can only have equal root if what? D equals to 0. And what is my d? My d is what? B squared minus 4ac. If it's equals to 0, then you have what? Equal root. Yes or no? Yes, so from here, let's now find what is my b. My b is what? Minus 3 plus p. Are you seeing it? Also minus 4. What is your a here? 1. What is your c here? 1 plus what? 3p. Everything must give me what? 0. So if I open this one here, I hope I should have this as my answer. It should give me 9 plus 6p plus p squared. Are we together? Minus 4 open bracket 1 plus what? 3p equals to what? 0. Yes or no? Yes, sir. Then if you collect like terms together and expand, so you have p squared plus 6p plus 9 minus 4 minus what? Minus 12p equals to 0. I have p squared 6p minus 12 will give me what? Minus 6p. 9 plus this will give me what? Minus what? Minus 5. No, plus 5 equals to what? 0. Are we together? And so from here, so if I will factorize this, so this will give me what? P squared, by factorization, you can know that this is P minus 1, P minus 5 equals to 0. Yes or no? Yes, so that's, okay, that's the proof that everyone can factorize. Clap for yourself for that. You can say that P is equals to, so from that, If you equate both of your answers to 0, so that means P is equals to 1 or P is equals to what? 5 as the final answer. Do you understand? Yes, sir. That is the value of P that can make that equation have what? Equal root. Another question. Are we ready? Yes, okay, let's write fast. Next question I want to call. Find the values of P. That's next question. Find the what? Value of P for which the equation are we together? For which the equation into bracket x minus 2 and another bracket x minus 3, for which the equation into bracket what? X minus 2 and sorry about that, and another bracket x minus 3 equals to what? Equals to P. Find the value of P for which the equation x minus 2, are we together? Into bracket, open another bracket, x minus 3 equals to P. Are we together? As roots which differs by 2. As roots which differs by 2. As roots which what? Differs by 2. Are we together? Okay, good. From here. So what was the question I have? I had that at x plus 2, no, minus 2, yeah, equals to what? P. So that they have it, that they write it, this question is written in such a way that the difference of their root is what? Is 2. Are we together? So first of all, let's expand this equation. So by expanding this equation, what do I have? X squared, s squared, minus 3x minus 2x plus 6 equals to what? P. Okay, x squared. And so from here, what do I have? I have x squared minus what? 5x plus 6 equals to what? Z equals to P. So from this, don't forget, they said that the difference between the root is what? What is the difference between the roots? 2. That means the root is written in such a way that, so the first is alpha minus beta is equals to what? 2. That's what they told us there. Yes or no? Yes, sir. Good. So if I want to write this one very well, I can write this one as what? X squared minus what? 5x plus 6 minus p equals to what? 0. Yes or no? Yes, sir. Good. From here. So now, if I want to find this, then what would my alpha plus beta be here? My alpha plus beta is what? Minus b over what? A. Yes or no? Yes, sir. Which is the same thing as what? Minus 5 over 1, which is the same thing as what? Plus 5. Yes? I can say that alpha plus beta is equals to 5. And the same thing, alpha minus beta equals to what? 2. So if I add both sides of this equation, what do I have? I have 2 alpha equals to 5 plus 7 equals to 7. Yes or no? Yes, sir. Then here I can say that alpha is equals to what? 7 over 2. Then if alpha equals to 7 over 2, let me put it in equation 2. And alpha minus beta equals to 2. what's my alpha here? 7 over 2 minus beta equals to what? 2. And then I can have what? 7 over 2 minus 4 over 2 equals to b. How do I get minus 4 over 2? Another question. Next one. Are we ready? Okay. Yeah, you can. One thing about mathematics is that mathematics is not rigid in terms of its method. You can if you want to. Now another one. Ready? Okay. Form the quadratic equation. form the quadratic equation. Out there. Form the quadratic equation for which the sum of root is 5. Form the quadratic equation for which the sum of root is 5. Are we together?
Yes, sir.
And the sum of the squares of root is 53. And the sums of the squares of root is what? Is 53. Do we get the question? Okay. Uh, 25 minus 53 is what? Minus 22. Minus 28. Then alpha beta here is equal to minus 14. Yes or no? So if alpha beta is minus 14, don't forget, if you want to form roots, if you want to form equation, what is your formula? X squared minus what? Alpha plus beta x plus what? Alpha beta equals to what? 0. And from here you have x squared minus, what is your alpha plus beta there? 5x plus, what is your alpha beta there? Minus 14. Your final answer is what? Do you have anyone with past questions for quadratic equation? Past questions with quadratic equation. Do you have anybody with that? Okay, nobody. Okay, you do. My friend. Write this question down. Find the roots of the equation. Find the roots Find the root of the equation x squared minus 3 open bracket x minus p. Find the roots of the equation x squared minus 3x, are we together? X squared minus 3 open bracket x minus p close bracket equals to 0. Find the root of the equation x squared minus 3 open bracket x minus p equals to 0. Are we there?
Yes, sir.
If one of the roots is 3 less than twice the other, if one of the root is what? 3 less than what? Twice the other. Which one should I clean? So let's write the equation. What is the equation? Are we? So from here, so I have x squared minus 3x plus 3p equals to what? 0. So alpha plus beta here is equal to what? Is equal to 3. Yes or no? Abi now? So let's now interpret that word problem that they gave us. They said that if one of the roots, that is, let's say alpha, is 3 less, that is, than twice the other, that is, alpha is equals to 2 beta minus 3. Abi now? Abi now? So from here, so if I have this, so it's just substitute this one back inside this place, then you can have 2 beta minus 3 plus beta equals to what? 3. Are we together? Then what do I have here? 3 beta is equals to what? 6. And beta is equals to 2. Right? Then alpha is equals to what? 1. Yes or no? Yeah? Alpha plus beta is 3, not minus 3. Because alpha plus beta minus b over a minus minus 3 over 1. 3. Happy now? How do I get what? How do I get alpha? This one here. If you read the question says that one of the roots is 3 less than twice the other. Now that I get alpha, if you have gotten beta equals to 2, substitute your beta into any of the equation to get your alpha. And I did that by putting it inside what equation? Inside this equation here. Because I know that 2 times 2 will give me 4, 4 minus 3 will give me what? 1. Yes or no? What the question asks us to find? Now this is the root. Yeah, if we use the root, we can also solve the problem. Okay. Now for me to solve the problem, I have to know my p first, right? So let me find p. So p, I can say that 3p is equals to 2 times 1. Yes or no? So 3p is equals to what? 2, and p is equals to what? 2 over 3. Then I put this back here, so I have x squared minus 3x plus 3 open brackets 2 over 3 equals to 0. Then what do I have? X squared minus 3x plus what? 2 equals to 0. Yeah, because you know that your quadratic equation is always written in form of x squared minus sum of roots blah 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 equals of roots. Get same way I did in which example like that? I think same way I did in one concluded example, same way I did in the other one. I already knew that my sum of roots is equals to p. I mean equals to 3. And the next one is that it's just to equate your constant to your what product of roots. What I did. So now, this time around, so look as if you have treated everything that has to do with quadratic equation. Alright, let me ask before I continue. Are there any questions anywhere so far? About some quadratic equation somewhere you feel to should solve, you have not solved, raise up your hand, bring questions, and let's continue. Yeah, let's be fast about that. Yes, what question is that? Yeah, question number 1 is more of polynomial. I've seen it, but not quadratic equation. I'm saying I will enter polynomial. It means more. That's where I'm going now. Anyone else? Anyone else? Going twice. Ma? Yes. I think we just had one. We had an example of one. I think x squared equals to x minus 6, if that's correct. Abi now? X squared equals to x. I can't remember the question. X squared equals to what? X plus 5, yes. If you solve that equation using your general formula, you end up having square root of a negative number, which will give you a complex solution. No question again. Okay, let's talk about polynomials. Polynomials. Now polynomial can be defined. Let me change your vista about polynomials. Now that in quadratic equation they told you that when you were in secondary school they told you that your polynomial is when the power of your unknown is greater than 3. Yes or no? I just want to call my name. Okay. 1. Now you know that in secondary school they told you that how do you know your what is it called? How do you know your polynomial? They told you that polynomial there is when the power of x of your unknown is what? Is greater than 1. So and we carried that definition for a long time until now, which I'm about to change. Now polynomial is not when the highest power of your unknown is greater than 2, polynomial can be defined as the family of equations with different respective powers in their unknowns. Polynomials can be defined as the word family of equations or expressions. Let's be more general now. A family of equations or expressions. Are we there? Family of equation or expression with different value, with different I called something now, with different highest power in their words, in their with their respective different highest power. Yes, I think that would be a good English. With their respective different words, highest power. Are we getting that? With their respective different words, highest power. That's when you have a polynomial. So now a polynomial does not really mean, so you can have a polynomial of degree 1. A polynomial of degree 1 is a polynomial in which the highest, in which its highest power is what? Is 1. And that is what? A linear equation. Yes or no? Now a polynomial of degree 2, a polynomial of degree 2 on the other end is known as a what? Quadratic equation, because the value of its highest power is what? Is 2. Yes or no? Now a polynomial of degree 3 is a polynomial which the highest power is what? Greater than, which is what? Is 3. And that name is what? Is a cubic equation. Polynomial of degree 4 is called a what? Quartic equation. Degree 5, if quartic, 5 is quintic, 6 is sexic, and 7 is septic, 8 is octic, nonic, a decic equation. I get what I'm trying to say like that. Just know that a general name for all equations with their respective highest power is known as what? Polynomials. You get what I'm trying to say like that? Okay, good. So with that, let's now move on to algebra of polynomials. So algebra of polynomials. Should I use algebra now? Don't use algebra, use arithmetic. Arithmetic of polynomial. So in the arithmetic of polynomial, first of all, we'll be dealing with what? Addition and subtraction first. Then after examples, we'll move on and we deal with multiplication and what? And division. Are we together? Okay, now question. Now I hope you know what I'm talking about. The first thing we're talking about is what? Addition and what? Subtraction. The question number 1. Question. Given that P1 of x, given that P1 of x, given that P1 of x, are we together? Number 1, given that P1 of x equals to 2x cube, given that P1 of x, that P1 of x means P1 open bracket to what? X, given that P1 of x equals to what? X cube, are we together? Minus 4x squared minus what? 4x squared plus 3x minus 2 minus 2. Are we there? And P2 of x and P2 of x and P2 of x is are we together? And P2 of x is equals to 4x cube And p2 of x equals to 4x cubed minus 2x squared plus 3x. 4x cubed minus what? 2x squared plus what? Plus 3x. Are we together? I thought about 3x, Abby. Plus 7. So we have a p1 of x, a p2 of x, and there was a, let's create a p3 of x, and p3 of x is equal to, and p3 of x is equal to, and p3 of x is equal to, and p3 of x equals to x squared minus x squared minus 4x minus 5. X squared minus 4x minus what? Minus 5. Evaluate the following. Number 1, p1 of x plus p2 of x plus p3 of x. p1 of x plus what? p2 of x plus what? p3 of x. Number 2, p1 of x minus p2 of x minus what? p3 of x. Are we together? That's number what? Number 2. Number 3, number 2, p1 of x minus p2 of x minus p3 of x. Number 3, 2p1 of x, 2p1 of x minus 3p2 of x minus 3p2 of x plus 4p3 of x plus 4p3 of x. Number 4, 2p2 of x, 2p2 of x minus p3 of x, 2p2 of x minus what? p3 of x plus p1 of x plus p1 of x is equals to, don't put equals to, I think that's all. That's how many? And the last one, p3 of x minus 2p2 of x plus p1 of x. How to get that? Okay, let's start solving. So where's p1 of x? X cubed minus what? Yeah, minus what? Plus. Okay. P2 of x is what? Okay. What the P1? What is question 1? So what is P1 of x here? X cubed minus what? 4x squared plus 3x minus 2 plus 4x cubed minus 2x squared 3x plus 7 minus 5. So if you add up here by collecting like times together, you have x cubed plus 4x cubed will give me what? 5x cubed. Now minus 4x squared minus 2x squared will give me what? Minus 6x squared. So minus 6x squared plus x squared will give me what? Minus 5x squared. Then 3x plus 3x is what? 6x. 6x minus 4x is what? Then what do I have here? Minus 2 plus 7 is what? And 5 minus 5 is what? So I think this should be your what? Final answer. Are we together? Then for me, plus 2. What's number 2? So let's go. What's P1 of x? So you have x cubed minus 4x squared plus what? 3x minus 2 minus here 4x cubed minus what? 3x squared plus 3x plus 7 minus again are we together? Then from here, if you open your bracket, you have what? S cubed minus what? 4x squared plus what? 3x minus 2 minus 4x cubed, Abby? Plus 4x squared, no? Plus 2x squared minus 3x minus 7 minus x squared plus 4x plus 5. So let's collect like terms together. So collect like terms together. So I have s cubed minus this will give me what? Minus 3s cubed. I have minus 4s squared plus 2s squared. That's minus 2s squared. Minus this one will give me what? Minus 3x squared. Yes or no? And the next one is what? 3x minus 3x will cancel out. And I've left what? Plus what? 4x. Are we together? And minus 2 minus 7 will give me minus 2 plus 7 is what? 5. Abi now? Minus 2 plus 7 is what? 5. Right? Abi? Minus 2 minus 7 is what? Minus 9. Minus 9 plus 5 is what? Plus 4. So that you write answer like this, or you write it with positive first. Minus 2 minus 7 is minus 9. Minus 9 plus 5 is minus 4. Do you understand, please? Okay. Question 3. What's question 3? Eh? Eh? So now from here, you have 2. So what's P1 of x, please? S cubed minus 4x squared plus 3x minus 2 minus 3. What is P2 of x, please? Abi? Then last one what? Plus what? 4. This is what? S squared. So open the bracket here. That's 2x cubed plus Collect like times together, so we have 2s cubed minus 12s cubed will give me what? Minus 10s cubed. Then minus 8x squared plus 6x squared will give me what? Minus 2x squared plus 4x squared will give me what? Next one, 6x minus 9x is what? Minus 3x minus 16x is what? And the last one, minus 4 minus 21 minus 25 minus 20 is what? So what is number 4? Mm-hmm. Now 2p2 of x, so you have 2. What is p2? Minus 3. What is p3? Then plus what is p1 of x? X cubed minus 4x squared. So yeah, okay. If you open bracket here, so I have 8 here. 8x cubed plus x cubed will give me minus 4x squared minus 3x will give me what? Minus 7x squared minus 4 squared. Then 6x plus 12x will give you what? 18x plus 3x will give you what? And the last one here, 14 plus 15 is what? 14 plus 15 is what? 29 minus 2. What's number 5? P3 of x, So what's P3 of x? Minus 2, what's P2? Four x cubed. X cubed minus 4x squared. So if you open bracket now, then open that bracket here. So let's collect x squared plus 4x squared. 5x squared plus 5x squared minus this. X minus 4x minus 6 as well. Minus 10x. Minus 10x plus 3x as well. And 5 minus 14 as well. 5 plus minus 19 minus the minus 8x cubed plus x cube you're giving us. So that's the first part. Is doesn't matter. So the multiplication part now. Multiplication part. So we are still using that same values of P1, P2, and P3 of x. So number 1. So we are going to product part. So for number 1, find P1, P2. I will want to find number 1, find P1, P2. Number 1, find P1, P2. Number 2, P2, P3. Number 3, P1, P3. Number 1, find P1, P2. Number 2, P2 was P3. And number 3, P1, P3. Number 4, P1, P3 minus 2P1, P3 minus 2P2, yeah, minus 2P2, P1. P1, P3 minus 2P2, P1. I hope you know that P2, P1 is the same as P1, P2. Eh? Eh? That's number 3, Abby. Let's create number 5. P1, P3 plus P2, P3 plus P1, P2. Are you there? P1, P3, are we now? Plus P2, P3, plus P1, P3. Number 1. This thing might look as if we are wasting our time, but we are not. We are learning. Are we together? So now, what's P1? I think my P1 of x Then what is P2? First cube. The question one says you find what? So I have here to be open bracket x cubed minus to multiply let's take it term by term. X cube first. You just keep to multiply everything here. So I have what? 4x6 minus 2x5 plus 3x4 plus 7x3. Now next one again, minus 16x5 8x4 fx3 okay. 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 So from here, what's the highest? So after 6, I went 5 to have. I have minus 2x5. So that'll give me what? Now how many 4s do I have? 3x4 plus 8, that's 11. I mean now. Plus 12, that's what? 23. Cube 7 minus 12, that's what? Minus 5. Minus 5 minus 6 will give me what? Minus 11. Minus 11 minus 8 will give me what? Now x squared now. Minus 28x plus 9. Minus 28 plus 9 will give me what? Minus 19, Abi. Minus 19 plus 4x squared. And how many x do I have? 21x minus 6x. 15x. Then I think the only number I have here is what? Right? P3 of x is equal to what? Number 2 is what? So P2 is Abi now. Ready? Yeah. Let's go like times 4x5. How many x do I have? Minus 16 minus 2. Now x give how many? Minus 20. As much? Minus 12. Minus 12. Minus 9. Squared. Then x. All together. Are we together? Alright, where's number 3? What's P1, P3? Ready? Yeah, let's go. Sounds correct like times scalar. Minus 5x. This is what? 11x. Abi? Plus 3. Now this squared. Minus 20, which is what? 8. Abi? And the last one, which is what? X. Abi? Minus 15 plus 8. Number 4. Minus 2. What's P1, P3? 2. What is P2, P1? And from here, I've been now. Mm-hmm. Okay. 15. I've on 5. X is 4. What's number 5? So let's do it step by step. I think P1, P2 is only 1/6. Have you now? That's 6. Now, then the next one is 5, have you? Minus 18 plus 4. Maybe everything's adding each other, nee? Everything's adding each other now. It's not as if there's minus in between. Doesn't matter. Minus 18 plus 4. That's minus 14. Minus 14 plus 1. Wait, calm down. Where are you talking from? Where is this one? P1, P3. This is everything is P1, P3 now. Okay, sorry. That's finished, have you? Okay, good. Now, I've added x5. Now, x4. 23x4. All together. Minus 18. 23 minus 18 is what? 23 minus 18. 5, Abby? 23 minus 18 is 5. Now, 5 minus 80 is what? Now the next one here, cube, minus 19, minus 9 is what? Minus 28, minus 5. Abi? Minus 28 plus 14. That's minus 14. Squared. Minus 15. Minus 10. X now. 15 minus 43. Happy now. 15 minus 43 should be 28. Minus 28. Minus 14 minus 35. Minus 49 plus 10. How to get that, please? Sit down for a minute. How will you write in this part? I want to do division of I want to do division now. For this division, in this division, we are going to recall our primary school long division method. We are going to call back into existence. Are we together? So let's see how many of us really understood it then. Suppose you have this. Which one do you divide first? 20 is what? 1. 1 times this was Abi? Abi now? Which you give me what? 1. 2 cannot go in 1. Put 0. 2 in 10 is what? 5. Abi now? That's 10, 0. That's 5. 2 in 5 is what? That's what? 4, remainder 1. Yes or no? Good. Same way we are doing everything here, it's the same way we are doing our normal division. Give me a manual, let me pick division from a manual. Carry out the following divisions. Carry out the following divisions. Number 1. Are we there? X squared plus x plus 2. X squared plus x plus 2 divided by x minus 1. Number 2. 2x cubed plus x squared minus 3 divided by 2x minus 1. That's 2, Abi. Okay, let's work with number 2 first. I'll do that. Yeah, what is this? Eh? X squared plus x plus. Whenever I want to divide, listen no. Whenever I want to divide polynomial, listen no. Whenever I want to divide polynomial, this is what you will do. You pick the first term of what is inside here, and you pick the first term of what is inside here, outside, and you divide it. Are we together? So what's the first time here? I'll give you what? X. X times x will give what? X times 1 will give you what? What do? I subtract both sides. Abi now? And so give me plus Abi. So give me what? 2x plus 2. And the next one, pick first time and first time here. 2x over what? X. Plus 2, Abi. That's what 2x minus 2. When I subtract both sides, I'll be what? So I think, so if I now want to write x squared plus x plus 2 divided by x minus 1, what is the answer here? X plus 2 plus what? 4 over x minus 1. Abi now? Eh? Abi? Are we together? So, from here, the next thing that so I'm done with this. So example number 2. So what is that? Eh? Minus 3 like that. Then divided by what? Please, for easy sake, whenever you see that it's not from the highest to the lowest, and there are some middle terms, you write that your divisor, your dividend. You can write it as this: 2x cubed plus what? X squared plus what? 0x minus 3. Altogether, please. 0x is still the same as 0 now. So what is common? The first time here, which is, so let's keep over what? 2x, yes or no? What I be left with what? X squared. The next thing, what would that give me? 2x cubed minus what? X squared, yes or no? Minus, what would I have here? 2x squared plus 0x. Are we together? So what do I have here? I have 2x squared plus 2x. And I add what? Plus what? X. Then what do I have here? 2x squared minus what? Minus x. By subtract both sides, what do I have here? X now, yes or no? Then you can bring this one to minus 3, yes or no? Then what do I do again? X over what? 2x. What do I give me? Plus 1 over 2, yes or no? Then 1 over 2 times this will give me what? X minus 1 over 2 times 1 is what? 1 over 2. If we subtract each other, 3 minus 3 plus half is what? Minus 2.5. So if you write this answer here, your answer is what? X squared plus x plus half minus what? 2.5 over what? 2x minus 1. Can you understand? You say no. Where don't you get? Now minus here will give you 2x. Then pick this one and divide this one. And continue the process. Go. Oh, that'll be my answer. I get z square. From where? It's not to where does it 2x square? This place here. X here multiplied by everything here. Anything else? X divided by 2 over x. Because that's how I've been doing it before now. The first divided by the first. First divided by the first. This one too divided by that. Now factor and remainder theorem. So in factor and remainder theorem, there's a way it is always written. But I don't think I can remember. Those ways they were written now. But look at the examples that talks about factors and remainder theorem. Okay, let's see if we can give it a definition. Factor and remainder theorem. Let's see if we can give it a definition. Are we ready? Okay. Suppose a function f of x. Suppose a function f of x. Are we there? Suppose a function f of x, are we there, is to be divided by a function g of x. Are you there? Is to be divided by a function g of x, comma, if after g of x, if after g of x, are we together? If after g of x being equated to 0, if after g of x being equated to 0, use a solution in terms of x, yields a solution in terms of x. How is it? Use a solution in terms of x, which is then substituted into the value, which is then substituted into f of x. Substituted into f of x. Full stop. If after the substitution f of x yields 0, if after the substitution f of x yields 0, are we there? Then we can say are we there? Then we can say g of x is a factor of f of x. I say g of x is a factor of x. Full stop. If otherwise happens, that is, after which g of x equated to 0, if otherwise stated, read that line again, please. After g of x being equated to 0 and substituted into f of x, are we together? And substituted into f of x does not yield 0, at a final result in f of x. Does not yield 0 as a finite result in f of x. Are we together? As a finite result in f of x. As a finite result in f of x. Are we together? As a finite result in f of x. Are we together? But yields any other value are we there? Then we can say that g of x is not a factor of f of x. Altogether. Okay. When do we stop? Yeah, let's continue. Where did you stop?
Then we can see that g of x is equal to factor of
F of x. Okay. And the result yielded. And the result yielded after the substitution. And the result yielded after the substitution. And the result yielded after the substitution is its remainder. And the result yielded after the substitution is what? Its remainder. So I have full stop. So the notes might be much. I mean now, that's my code. But I have just explained what factor and remainder theorem means. So can we all read it out loud once more from the beginning to the end? So that we can look at how organized it is. Alright.
function f of x is equal to function g of x. If after g of x we equate x to 0, use a solution in terms of x, which is then substituted into f of x. If after the substitution f of x is 0, then we can say g of x is the factor of f of x. If otherwise happens, that means after g of x is equal to 0 and substituted into f of x does not yield 0 and finite result in f of x. But use any other value, then we can say that g of x is not a factor of f of x, and the result yielded after the substitution is the remainder.
Alright, I think that sounds perfect. Okay, so that's factor and remainder theorem. So let's now put it to words. Explains in maths. Now, whenever you want to divide two functions, one function divided by another function, the first thing you have to do to check whether one function is a remainder of the other function is that, first of all, try as much as possible to equate the other function into 0. Okay. Okay, let's check. Let's do these examples. Okay. Solution. Out together. Now I want to use these 4 examples on the board to explain that thing we meant by factor and remainder nonsense we just said. It's not nonsense, so don't call it nonsense. So I just said it like that. Now first thing is that whenever I want to differentiate a function by another function, Abi, how many functions do you have here? 2 functions, yes or no? First thing you're supposed to do is that equate your divisor to 0. This is your dividend, this is your what? Divisor. Yes or no? Equate your divisor to 0. So I have here to be x plus 1 equals to 0. So this was the f of x being divided by what? The g of x that I was talking about earlier. Are we together? Yes, then so from here, after I've equated it to 0, next thing is that solve for x. The one I have here, I have x equals to what? Minus 1. This is the value that I'm telling that after you've substituted, equated your g of x to 0, you get an answer in terms of x, which is this. Are you getting it? Now, if after you have gotten this, you now substitute back into your answer here, and you get 0, that means this one here is a what? It's a factor. If after it did not give you 0, it means that this one here is not a factor, and whatever answer you get will be your what? Remainder. Okay, let's look at that. So from here I have 2 open brackets minus 1 squared plus minus 1 minus 1. This gives us 2, 1 minus 1 minus 1, which is giving me what? 2 minus 2 to give me what? 0. So because I had 0 here, so that means that x plus 1 is a factor of 2x squared plus 1. 2x squared plus x minus 1. Yes or no? Yes, sir. Alright, good. Now let's look at let's look at the second one. So looking at the second one now, what do we have to do now? The second one says that, so let's start. We have x minus 1 equals to what? 0. So for me I have what? X equals to what? 1. Yes or no? Substitute this answer inside this space, then what do I have? 1 squared plus 1 plus 2. And at the end of the day I end up having what? 4. Yes or no? So this 4 is not the same thing as 0. Therefore, I can say that x minus 1 is not a factor of this one here. And 4 is what? Is the remainder, which was what you got here after you performed the long division method. Do you understand? Yes, sir. Good. Now number 3. For number 3, what do we have? We had 2x minus 1 equals to 0, and for me I had what? X equals to what? 1 over 2. Yes or no? Yes, sir. Substitute that answer inside this place. What do I have here? I have 2 open brackets 1 over 2 squared. It's not cube. The cube. It's cube. Okay. Cube. Are we together? Plus 1 over 2 squared. Are we together? Minus 3. So what I have 2 open brackets 1 over 8 plus 1 over 4 minus 3. And this is what? 1 over 4 plus 1 over 4 minus 3. And this is giving me half minus 3, which is the same as what? Minus 2.5. Yes or no? Yes, which is exactly the same thing I got in this place when I divided. Are we together? Yes, sir. And for the last part, let me just box the last part here. This is number 1, number 2, number 3, number 4. So what do I have? I have x minus 2 equals to 0. So what do I have here? X equals to what? 2. I'm putting that 2 inside this space. What do I have? 2 squared plus 5 open brackets 2 minus 6. Are we together? Yes, sir. And this is what? 4 plus 4 plus 10 minus 6. 14 minus 14. 4 plus 10 is what? 14. 14 minus 6 is what? 8. So this 8 is what? The remainder as what? X plus, as x minus 2 is what? Not a factor. Do we understand? Yes, sir. Wow, 60 hours. That's nice. Thank you very much. Thank you very much. Let's continue. So, okay. So we are done with that part. So let's now take more examples on it. Are we together?
Yes, sir.
I hope you now understand the concept of factor and remainder theorem.
Yes,
Okay, let's look at some examples on it again. So someone gave me a phone that's manual has PDF earlier on. Someone gave me manual that's a phone that's PDF. Please, I'll need the phone. I will need the phone quickly, so that I can call questions. Oh, yeah, sorry. But the phone is locked now. And it's Sister Daniela's staff has called. Just away. Can you take? Let me give him. I put this in your thing. Put it in the board. Okay, thank you. Alright, let's take down these questions. Find in terms of k, number 1. Find in terms of k. Question 1. Find in terms of k. Find in terms of k. Find in terms of k. Are we getting it? The remainder. Find in terms of k the remainder when 2x squared plus kx minus 6, when 2x squared plus kx minus 6, when 2x squared plus kx minus 6 is divisible by, is divisible by 2x plus 1. Is divisible by what? 2x plus 1. Okay, let's start with that. Now the first thing that they ask you to do is this. Write out your function, which is what? 2x squared plus kx minus 6. And they said this one is divisible by what? 2x plus 1. So, and they ask me to find the remainder. What do they want me to do? They want me to first of all equate 2x plus 1 equals to what? 0, right? And I have x equals to what? Minus 1 over 2. And I have to substitute this answer back here. So what do I have? I have 2 open brackets, minus 1 over 2 squared plus k open brackets, minus 1 over 2 minus 6. And I have here 2 open brackets here. What do I have here? 1 over what? 4 minus what? 1 over 6k minus 6. Yes or no? And for me, I can have what? 1 over 2 minus 6 minus 1 over 6k. How to get that? Then half minus 6 is what? Minus 5 and a half. I mean now. That's 1 over 6k. Okay. Okay. How to get up? How to get up? So that's that about that. So, more questions? More questions? Are you ready? If x minus 1, if x minus 1, if x minus 1 and x minus 2, if x minus 1 and x minus 2, if x minus 1 and x minus 2, are we together? Are factors of, if x minus 1 and x minus 2 are factors of x cubed plus ax squared minus 7x plus b. Are we together? Where a and b are constants. Where a and b are what? Are constants. Find a and b. Find a and b. Find a and b. Find what? A and b. Are we together? Okay. Are we together? Now first of all, write out that function. So what is that function? X squared ax What are the factors they give you? Now, if you remember in that definition of factors I gave you, the only condition where I can have a factor is if after I've equated my divisor to 0 and I've substituted, the whole answer I get is what? 0. Yes or no? Let's do that. So I can now say that here, x minus 1 equals to 0. I would say x equals to what? 1. Putting the answer here, what do I have here? 1 cubed plus what? A 1 squared minus 7 1 plus b equals to what? 0. Why am I putting this equals to 0 here? Because the question here is telling me that what? X minus 1 is a what? A factor. Then so from here, what did we have? And I have 1 plus a. Are we together? minus 7 plus b equals to 0. Then you can take this one to the other side. I can say that a plus b is equals to 6. Yes or no? You can call this equation what? Equation 1. Then the other one too, x minus 2 equals to 0 and x equals to what? X equals to 2. Yes or no? Then if we put 2 there, what will I have? We have 2 raised to the power 3 plus 2 squared a minus 7 2 plus b equals to what? 0. So what do I have? I have 8 plus 4a minus 14 plus b equals to 0. 8 minus 14 is what? Minus 6. I mean now. So if I take that down to the other side, so I have 4a plus b equals to what? 6. And let me bring this one here, which is what? A plus b, which equals to what? 6. Yes or no?
Yes, sir.
So from here, what do I do? If I subtract both sides, I have 3a equals to what? 0. Yes or no? Then a is equals to 0. So if a is equals to 0, automatically what? B is equals to what? 6. That's the answer. All right. Another question. Another one. How is that? Find the value of k. Find the value of k. Find the value of k. Find the value of k if x plus 2 is a factor of. Find the value of k if x plus 2 is a factor of. Find the value of k if x plus 2 is a factor of. Are we there? The factor of x cubed Are we there? S cubed minus kx squared. Sorry, plus kx squared plus 6x minus 4. The question asks you to find the value of k if x plus 2 is a factor of what? X cubed plus what? X squared plus 6x minus what? 4. So look at the question. I got the question, please. I have got x plus 2 is a what? Is a factor. That means x plus 2 equals to 0. And I have x equals to what? Minus 2, right? I have minus 2 is power 3, right? Plus k minus 2 squared plus 6 minus 2 minus 4 equals to what? 0. Yes or no? Then from here, I have what? 8 plus what? 4k minus 8 plus 4k minus 12 minus 4 equals to what? 0. So 4k is equals to 4k is equals to 8. Abi now? Because minus 12, yeah, and k is equals to what? 2. Yes or no? Minus 12 minus 4 is what? Minus 16. Okay. That's 6. Another one. Oh yeah. If f of x minus 2. Another one. If f of what? X minus 2. That's f open bracket x minus 2 close bracket. If f of x minus 2. Oh yeah. Is equals to 3x squared plus 4x plus 1. Is equals to what? 3x squared plus 4x plus 1. Question is, find f of 1. Find what? Okay. So they told you that f of what? S minus 2 is equals to what? Are we together? I have to find what f of 1. Are we getting it? So whenever you have a situation like this, look up. Look up. Look up. Whenever you have a situation like this, I get what I'm trying to say.
Yes, sir.
So the next thing you have to do is what? Equate these two things to each other first of all. I get what I'm trying to say like that. So from there, I will have what? X minus 2 equals to what? 1. And x equals to what? 3. Yes or no? And after I've gotten this answer of x, put this answer here back inside this place. Do you understand? Let's come again. Let's come right one more time. When you have something like this, the first thing that you have to do is what? Equate both of them together. All together. After you have equating both of them together, you get an answer. And the next step is what? Input the answer inside your question. What will I have here? I will have what? 3 open bracket what? 3 squared plus 4 open bracket 3 plus 1. Yes or no? Yes, this is going to give me 3 raised to power 3, which is what? Away 27 plus what? 12 plus 1. The 27 plus 13 should give me what? 40. Okay. Next one. If, are we together? If x plus 2 and x minus 1, if x plus 2 and x minus 1, if x plus 2 and x minus 1 are factors of the expression, if x plus 2 and x minus 1 are factors of the expression, are we together? Are factors of the expression ax squared plus 2kx squared, sorry, it should be ax cube. Ax cube plus what? 2kx squared. Then plus what? Plus what? Plus 24. Are we together? Find the value of a and k. Find the value of what? A and k. We had this one first, which was what? Are we ready? So now they say that these are what factors of this equation. So I can now start that when, what is this, x plus 2 equals to 0, what do I have? X equals to what? Minus 2. So putting that here, I can have a open bracket minus 2 cube plus 2k, sorry, plus 2k minus 2 squared. Are we together? Plus 24 equals to what? 0. What do I have here? Minus 8a minus what? Okay, minus plus 8k. Are we together? Plus 24 equals to 0. If I divide or take everything to the other side and divide by 8, you have a minus k is equals to 3, equation 1. Have you now? Next one. When x equals to what? Sorry, when I have x minus 1 equals to 0 and x is equals to what? 1 here. So I have what? A open bracket 1 cube plus 2 cube open bracket 1 squared plus 24. What do I have here? I have a plus what? 2k plus 24 equals to 0. And then I can have what? A plus 2k equals to what? Minus 24. Equation what? 2. Are we together? Which one am I bringing down? Which one? Let me bring this one here under this one. A minus k equals to what? Equals to 3. Then if I subtract both sides here, then I have what? 3k equals to what? Minus 27, and k equals to what? Minus 9. Then what do I have here? I have a minus 9 equals to 3, a plus 9 equals to 3, and a equals to what? Minus 3. Okay, sorry. Minus 6. How many questions so far? We lost count. I can't find the count. 9. Let's continue. Another one. If sorry, if f of x Thank you. Thank you. Altitude. If f of x if f of x is equals to 1 over x minus 1 plus x minus 1 over x squared minus 1, find f of 1 minus x. Yeah, can we start? Now first of all, let's break this one down. F of x equals to 1 over x minus 1. But this is x minus 1. This is difference of 2 square, which is x plus 1 over x minus 1. Yes or no? Where these two can cancel out, then I'll have f of x equals to 1 over x minus 1 plus 1 over x plus 1. Yes or no? Then I can have f of x is equals to x minus 1 x plus 1. I can have x plus 1 plus x minus 1. I can have f of x here is equals to what? 2x over what? X squared minus 1. Yes or no? And the question asks me to use this one to find f of 1 minus x. So what would so f of 1 minus x will now give me 2 open brackets 1 minus x open brackets 1 minus x squared minus 1. I have 2 plus 1 minus x, and everything will be 1 minus 2x plus x squared minus 1. Have you now? Now I'll be left with 2 open brackets 1 minus x Wow. What's common here? X. Then what do I have? 2 or minus 2 plus x. Are we together? I don't think there's anything I can do to this one again. Which is 1 minus x divided by 2 over x over bracket x minus 2. Yes or no? That's my final answer. No. Which one? No. You can't. Because in that first question that we were given, we're not given a specific function of x. They give us, I'll call it an abridged version of f of x. What you have here is a complete and direct function of what? Of x. So that doesn't mean that if we equate them together, we get the same thing. No. You don't get the same thing by equating them together at all. Another question. Find the values of p for which the equations find the values of p for which the equations find the values of p. Are we together? For which the equations find the values of p for which the equations are we together? X squared, or equation x squared minus p minus 2x. Now x squared minus open bracket p minus 2x, p minus 2 inside bracket, sorry, x squared minus p minus 2 close bracket x. Are we together? Plus 2p plus 1 plus 2p plus 1 equals to 0. Equals to 0. Are we together? As equal roots. As equal roots. Are we together? Look, can we have that equation, please? Plus. Hmm? So what is your A here? B is what? B? And C is what? And they told the equal roots. So for equal roots, it means that what? D equals to 0, or what? Or B squared minus 4AC equals to 0. Are we together? 4 is here, minus P minus 2 all squared minus 4, 1, 2P plus 1 equals to 0. This mic says together. Let's write the other one. So what was the equation we were given? Bx squared plus what? Plus what? I like them as they change the order of this question. I remember if some people still see this question in the option and they see the original general formula, they will still go and pick it. Whereas I feel it. The question does not want you to do like that. What the question wants you to do is this. So if you write this one in terms of your A here is your what? B, yes or no? Your B is your what? C, and your C is your what? A. And so that x equals to minus b plus or minus square root of what? B squared minus 4ac over what? 2a. And your x here equals to, what's your b? So minus c plus or minus square root of what? C squared minus 4 open bracket b open bracket what? Ba, right? Divided by what? 2b. And your x here will give you minus c plus or minus square root of what? C squared minus 4ab over what? 2b. In today's class, all right, so the next 15 minutes, let's push ourselves to partial fractions, and we won't take deep. Where's my duster? All right. So partial fractions. There are about how many forms of partial fractions? About like, let me see, 1, 2, 3, 4. Okay, there are like 4 forms of partial fractions. The first form of partial fraction is when you have solutions, you have linear functions in the denominator that are not repeated. That's number 1 type. And the second type is you have functions in the denominator that are what? That are repeated, yes or no? And the third one is when you have an unfactorizable quadratic expression, yes? And the last one is when you have an unfactorizable quadratic polynomial. Let's look at some partial fractions here in your manual. Let's deal with some of them. Are we together? So first of all, let's rewrite this one. So I think this is simple as saying 4 divided by x squared plus 5x minus 14. Yes or no?
Yes, sir.
Then I think if I have minus 14 here and I have plus 5, so that is, it can be factorized to give me 4 open bracket, that's x minus 2, x plus 7, right? Okay, good. And this one here is 4x minus 2, x plus 7 is equivalent to a over what? X minus 2 plus what? B over what? X plus 7. Are we together? So from here I can have 4 over x minus 2 open bracket x plus 7 equals to what? A open bracket x plus 7 plus what? B open bracket what? X minus 2 divided by x minus 2 x plus 7. Yes? Yes or no?
Yes.
Then from here, since the base are the same thing, I can equate the height, which is now going to give me 4 equals to what? A over what? X plus 7 plus what? B over what? X minus 2. So from here, we usually play hide and seek, but this day we decided not to. So we said that let set or let x equals to 2. Now kept it here. So what do I have? We had 4 a 2 plus 7 plus b 2 minus 2. 4 equals to a multiplied by 9 plus what? 0. We thought the person that had 0 had died, but no, that's a game. And you can say a is equals to what? 4 over 9. At the same time, we can also make it let x equals to what? Minus 7. Now 4 equals to a minus 7 plus 7 plus b minus 7 minus 2. I have 4 equals to what? Minus 9b. And b is equals to what? Minus 4 9. Yes or no?
Yes,
So from here, you would have 4 over x squared plus 5x minus 14 equals to, what is my a? Equals to a over x minus 2 plus what? B over what? X plus 7. Then this one too can be written as a open bracket 1 over x minus 2 plus what? B open bracket 1 over what? X plus 7. Yes? And here, where is my a? 4 over 9 1 over x minus 2 minus what? 4 over 9, 1 over what? X plus what? 7. Are we together? So I've resolved whatever I have there to a what? Partial equations. Are we together? 6x squared minus 3x divided by x minus x plus what? 4. Are we together? Are we together? And all of this can be equivalent to what? A over what? X minus 2 plus what? B over x plus 4, right? And you can have 6x squared minus 3x divided by x minus 2 x plus 4 all together is equivalent to a open bracket what? X plus 4 plus b open bracket x minus 2 divided by x minus 2 x plus 4, right? And from here you can have 6x squared minus 3x equals to a open bracket what? X plus 4 plus what? B open bracket x minus 2. So from here I'll say that let x equals to 2. So what do? You have 6 open brackets 2 squared minus 3 open brackets 2 equals to a 2 plus 4 plus what? B open bracket 2 minus 2. And this is 6 times 4, which is 24 minus 6 equals to what? 6a. So give me 18 equals to 6a, and my a here is equals to what? 3. Are we together? Then from here let x equals to what? Minus, what is that? Minus 4. Are we together? I have 6 open bracket minus 4 squared minus 3 minus 4 plus 2a minus 4 plus 4 all together plus what? B open bracket minus 4 minus 2. What is 6 open bracket 16 minus so plus 12 equals to minus 6b. 6 times 16, 96 plus 12 equals to minus 6b. How would this one give me? 108 equals to minus 6b, and b is equals to 108 divided by minus 6. Minus what? Minus 18. Are we together? So therefore we can now say that 6x squared minus 3x divided by what? X minus 2 x plus 4 is equivalent to a over what? X minus 2 plus b over what? X plus 4. I'm now be written as what? 3 divided by what? X minus 2 minus b, which is what? Minus 18 over what? X plus 4. Yes or no? Yes or no? So take. We still have a lot of examples to check. Let's quickly summarize the notes. So today we started by defining what? Polynomial, isn't it? Is it not?
Yes, sir.
And what do we call polynomials? We call polynomials what? What do we call polynomials now? So I can say we called a polynomial whatever you just said now, which I agreed. Although even if I did not hear half of what you said, but I agree that you wrote it down, and that was what I called. So then after that, what do we look again on that? We looked at what arithmetic of polynomials, where we did the additions, where we did subtractions, where we did multiplication, and where we did what division. And I think I remember that I specified that whenever you are dealing with division of polynomials, what's your working principle? Your long division. And I told you that whenever I want to divide, you start by dividing the first term by the what? The first time of your dividend by the first time of your divisor. Yes or no? Alright, then from there, then we'll now explain what factors and what remainder theorem. And so far so good. Ever since I've been teaching, that definition I gave you will be the best definition that I will ever give to explain factors and remainder theorem. If it were possible, I would literally have to, that I give you the definition. So I always make copies of the definition, but not as perfect as these definitions as I made. Probably I will have to write these definitions down and save it and give it to the next person I want to teach. Because very soon I'll be leaving, but that's not even where I'm going to. And after that, we looked at some examples on both quadratic equations, yes, and what? Look on examples at both quadratic equations and these ones. Before we now take a brief look at what? At partial fractions. Now partial fractions may look as if it's long or what it's asking you. But the real sense is that the real sense of partial fraction is that whether I like it or not, the higher you go, the more you require the knowledge of what? Partial fractions. For example, if you do integration in your second semester, partial fraction is part of your what? Partial fraction is part of the what? Method. I get what I'm trying to say like that. So being it part of the method, and if you don't know it now, it will what? Affect you then. So that's why it's advisable to take a look at what? Partial fractions, yes or no. So I don't know. So I advise that you start laying out some past questions and start solving as many questions as you can solve. So how many questions did we do so far today? I think I taught you how many times? I taught you twice today. Right? Abino, how many questions did we do so far today? Probably more than 20. 32. Away. That's nice. So, thank you very much for today's class. I love having to see you one more time in our midst. Alright, so you can leave for the next class. Last time we met on, let me see, okay. Last time we met on MTS 205. we talked about what? We talked about, I think we've trashed solutions to second order linear equation. Yes or no? Sorry? Permit me, I'm going to be a bit lazy today, in the sense that I'll be teaching, I'll stand and sit, stand and sit, stand and sit. I hope I'm permitted. So we started with that. So I think I said the other time that anytime we have class, be it MTS 205 or MTS 201, try as much as possible to do it, to attend the class. Yes or no? I think I said so now. Did I not? So please, just because the way I taught it the other time, I didn't really enjoy myself. It's why I want to teach it with you guys again. So, but today we'll be looking at Laplace. Right? We're looking at Laplace transforms. So Laplace transforms are defined in this format. So these are Laplace transforms are. They are denoted in this format. Are we together? So I think we have caught up with them in class now. Have we not? Happy now? Happy now? I think the only thing that we have not learned so far now is variation of parameters. And we'll learn that one. Probably not now. Or not today. Or maybe not in this session. But we'll do what? We'll learn it. Are we together? Now, this is the basic definition of how Laplace looks like. And one thing I want you to know is that, first thing, the most important thing here is that it's more than you knowing what to do. It's also involved in knowing how to write what you know what to do. Do you know what I mean by that? What I mean by that is that there are some cases that people will miss it. For example, look at that thing on the board. It looks like L, but it is not L. So what I'm trying to say is that you have to know how to write it. Laplace is not L. I guess what I'm trying to say like that. I repeat again. Laplace is not what? Laplace is not L. That you just have to just write L, Laplace, and you're going. No, Laplace is not L. You have to master that one. And also from here, since we have that, so this is what I will just do to favor you. I'll teach you how to apply this, your general formula. Then we'll prove some functions, probably 2, 3, or 4. I don't know. Then we'll continue with the class. Is that okay by us? Okay. And from here, I'll have what? Let's start. Now, first proof I want to prove here is when f of t is equals to k. That means I want to prove when it is an arbitrary constant. Then what do I have? So Laplace of k, are we together? Is equals to infinity 0. Are we together? Exponential minus st dot what? K dt. Yes or no? Then k coming out of your integration sign. Infinity 0 exponential minus st dt. Yes or no? Then from here, I can have k, and I have minus exponential minus st bounded by infinity and what? And 0. Yes or no? And this one here should give me k minus exponential infinity minus that's 0. Are we? Then from here I add k k, this one here as 0, and this one will give me what? Exponential. I'll get our pencil like that. Exponential 0. And at the end of the day here, I had what? I had k. No, this one should be over s. Over s. Over s. Over s. And from this gives I had what? K over what? K over s. That tells me that anytime I want to integrate a constant, or I want to find the Laplace transform of a constant, the answer will be what? That constant divided by what? Divided by s. Are we together? Okay. The second one I want to prove. I want to prove n of t is equals to exponential minus, let's say, exponential at. So what do I have? So I have Laplace of exponential at. Are we together? To give me, what do I have here? Infinity and 0. Exponential minus st multiplying what? Exponential what? At t. Yes or no? And because exponential are the same thing, so I have infinity and 0. Exponential minus, what do I have here? St plus what? At dt. Then here we'll have infinity and 0. Exponential t, open bracket, a minus s. Have you now? dt. Then from here, he integrated, and he told us that our share was 1 over a minus s exponential t a minus s. Are we together? As it was bounded from where? Infinity towards 0. And from here, we had 1 over a minus s exponential infinity minus 1 over a minus s exponential 0. Are we together? Then from here, I think this one here vanished, and we had 1 over minus 1 over what? A minus s. Have you now? Then gradually the minus integrated, and it became 1 over what? S minus a. Are we together? Okay. Now let's write that. I'll try that quickly. I'm waiting for it to write. We're done here. Do we have anyone that is in real time here? Like real time apart from stopwatch that is counting down? 1:13. Okay, are we ready? Are we done? Okay. I'm coming, give me a minute. Alright. So we have proven this. And since we have proven this, so the next one I want to prove again. Let's prove number 3, which is f of t equals to what? Exponential minus at. Then from here, I have the Laplace of what? Exponential minus at. Are we together? Equals to what? Infinity and 0. Exponential minus st dot what? Exponential minus at dt. Right? And everything here will have become infinity and 0. Exponential minus st minus at, right? Then the t, then it should have become, so what's that? It should have become infinity this exponential minus t s plus a, right? The t. Then here we might be lucky such a way that if we integrate, we might have minus open bracket s plus a exponential minus t s plus a bounded by what? Infinity and 0. Are we together? Then from here, what do I have? I'll have minus 1 over s plus a. Then here, our exponential infinity minus 1 over s plus a exponential 0. And unfortunately, he vanished and he left us with what? 1 over s plus a, which is our final answer for that. What? Are we together?
Yes, sir.
Okay. Then so from here, should we do one more proving?
Yes, sir.
Okay. Let's see. Let's see what will happen if I want to prove number 3. Now I want to, number 4. If I want to prove f of t, are we together? Equals to t itself. Are we ready? I want to prove this equals to t. What do I have here? I'll have Laplace of what? T equals to what? Infinity 0 exponential minus st dot t dt. And I think the best way that would have helped ourselves here was by doing what? Integration by part. Yes or no?
Yes, sir.
So by integration by part, I'll say that the u here, or let me say u here was t, and the v here was minus t dt. Are we together? And if I differentiated, so I add du equals to what? dt, and v here equals to what? Minus 1 over s minus st. Are we together? Then from here, splitting this one into 2. Can we see the board?
Yes, sir.
And I had uv, which is t dot minus 1 over s minus st bounded by what? Infinity and 0 minus integral v du minus 1 over s minus st altogether 1 over infinity and 0 dot dt. Are we together? And everything cancelled out. Then by the time I brought this one out, I had 1 over s, infinity of this. And I hope you know that by the time I will integrate all of this here, which are minus st dt. By the time I was done integrating everything, I had only what? 1 over s left. Yes or no? So that will be our answer when we integrate f prime f of t equals to t in this case. Now here, I want to look at our tabular form. Tabular form. Let's say that this one here will give you f of t, and here the Laplace of what? F of t. So that's what I want to look at now. So whenever you have k is what? K over s exponential at 1 over s minus a minus at 1 over s plus a. Now together?
Yes, sir.
Then, so I have sine at cos at slash 80 cos 80 and t raised to power n. C raised to power n is given as n factorial over s n plus 1. Are we together?
Yes, sir.
So what will be my MTS delta? So what will be the Laplace of sin 80? So a over s squared plus what? A squared. Cos will be s over s squared plus a squared. And sin should be what? A over s squared minus a squared. And cos is what? S over s squared minus a squared. Are we together? Waiting for us. So now, since we have gotten this table, we will now find Laplace of some different functions. How many examples did you do, my friend, in class at that time? Minus 15, 8. Okay. Let's have. Are we ready? Okay, good. So, worked examples. Or if you're done writing, just let me know. Why can't I? We can't now because obviously number one was when k was a constant. But this for doesn't really have to be the fact that probably is even rich or poor, the fact that it's human, and also in terms of t. Just like the same way you cannot just differentiate 6x exponential x as just 6x or 6 exponential x. You get what I'm trying to say? How is that? Laplace is c squared minus 1 all together, and Laplace can be shared. Laplace c squared minus Laplace of what? 1. Laplace of t squared will give you what? 2 over s cubed minus 1 over s. Number 2. Laplace of from here we have 4 t minus 2t. My answer here will be 4 t squared over s cubed minus so this will give me 1 over s plus not a here plus 2 plus what is that sign, and s squared plus 1, which is best is that's 4t. There's 4t here now. Maybe this is it. Over s and 1 factorial is so 4 over s squared. Maybe it is because I guess I didn't finish it then. Because I just assumed that I didn't finish it here. It should have 1 over s. Stop making noise, Shari. I was gonna.
Yes, sir.
Now, number 3.
Plus exponential 2c.
Laplace of
Laplace of exponential minus 3 plus Laplace of exponential 2c. Laplace of exponential 2c. S squared minus 2 squared.
Question number 5.
Laplace of
minus 4 cos 2t minus
Eh?
Laplace of sine 2t minus Laplace cos Laplace of cos 2t minus Laplace of 0 raised by 3 over s squared minus 4 minus 4 s numerator
Laplace of 7 squared minus 6 plus 20 cos 3. Laplace of 7 squared minus Laplace of 6 plus 20 Laplace.
Laplace of cos sorry 20
20 Laplace of
plus 7t
What's squash?
S over s squared minus 9 40 over s cubed minus 6s divided by 16z over s squared minus 9.
Harry? I'll sit down. Let me have this boy that is sleeping, please. So let's come back. I can answer that sine squared c is equals to what? 1 minus cos 2t over what? 2. The same thing as what? 1 over 2 minus cos 2t over 2 minus what? 2. Now taking the Laplace of 1 over 2 minus 1 over 2 Laplace of cos 2t minus Laplace of 2. This one is Laplace. Yes. Cos 2t. So, we are number 10, which is Laplace of 2 minus. Plus 2 exponential minus 2t. So, I think we should be able to generate an answer now without stress. 2 over s minus 1 over s squared plus 2 over s plus 2. Yes or no? Okay, good. Thank you. I don't who you know. Now let's go shifting theorems. I trust the writing, please. Hello. I know, let's write now. We just do more example than we did the other time. Do more. How's that? I'll be right. Yeah, you're right now. You shall let me explain first. Oh. I'm waiting now. See anybody that's sleeping by cash me. You will graduate instantly. Come on, Tish. Don't worry. We'll swap Bunday personality. Somebody also. Once you're done, I start. Please write fast, please. For easy mastery, so that I can help you guys. For each stuff we do a lot of examples. Where I did 10, where I did 7 for 315, I did 10 for 25. Where I did I think this one I did was 5. I mean, I did 5, I did 7. Wait. It's the one. So today is Saturday, abi? Wow. Eh? Let's start, please. So please, and let's look at this. How do we recognize when to use? They play my fan. I don't pay for this one. Now, this one, how do you recognize when to use shifting theorems? Now, one thing you will notice that when we're doing the first 10 examples of Laplace, they were all single functions of t. Yes or no? There was no case where t and probably t and one type of function were written close together. Or do calculation. So they stand in their own place. Now the first thing, notice that's why I said that first shifting theorem, that's why I gave it name, which is what? Multiplication of what? Exponential at or what? Exponential 8 minus at. I did not state this one 2315 so now I'm stating it. That's why each time I'm teaching, even if I've taught it before, come to the next class I will teach, even if it will be the same thing. It will be something different that we had. Or something different. And the thing is that if you go and check some textbooks use exponential minus at as part of their law. And you'll be like, what is this now? What I learned is not what I'm saying. So it is still the same thing. Now this is what will happen. Now, how do you recognize this? You recognize this in a way that exponential at or exponential minus at are always written together with any other very kind of function. If you look at all the examples I have on the board, see that one thing that all of them have in common is what? Exponential. They might not be the same exponential, but at least all of them had what? Exponential. I get what I'm trying to say like that. Now, how do you deal with this? The first thing that you do is that, first step, you will write the Laplace of both functions out. I get what I'm trying to say like that. And then, okay, should I say it or I should? Okay, let me say it. Then after you have written the Laplace of both functions out, the next step that you are going to do is that you will write, anywhere you see t, you put the denominator of the Laplace of the exponent in place of it, and you are done. Okay, let's do like that. Number 1, you have Laplace of 2 exponential 2t sine 4t. And I hope you know that this is the same thing as saying 2 Laplace transform of exponential 2t sine 4t. Now, the first thing I'm looking for here is like, look for the Laplace of exponential of 2t, which at the end of the day will give you 1 over s minus 2, and Laplace of what? Sine 4t, all together, which at the end of the day will give you what? 4 over s squared plus 16. Now, after I've done this, now, anywhere you see s on the other side of your Laplace, except from your exponential, you substitute the denominator of the Laplace of your exponential. Let me repeat myself. Anywhere I see s on the second function apart from what? The exponential, what do? I substitute what? S back inside. Are we getting this like that? So from here, so this one I cannot call that. So 2 Laplace of exponential 2t sine 4t. Now give you 2 multiplied by 4 over, except for s here, you have what? S minus 2 squared plus 16. And you can write this very well to give you what? 8 over s minus 2 squared plus 16. What's the final answer? Number 2. Laplace of t squared exponential minus t. As I said, find the Laplace of each of them separately. Laplace of t squared will give you what? 2 over. Yes, any question? Oh, okay. Then Laplace of exponential minus t, and that's going to give me what? 1 over s plus 1. Yes or no? I think that anywhere you see s in the order Laplace, except from this, what do you substitute inside? The denominator. Now, my answer here will not be Laplace of t squared minus t is equals to 2 over s plus 1 is by what? S power 3. Do you understand? Okay, number 3. Okay, now come to the other side here. Are you ready? Okay. So I've done 2. Okay, let's continue with number 3. What's number 3 there? Laplace of what? 3 exponential 40. Sin what? Eh? Sin t. Okay. This is same as 3 Laplace of exponential 40 sin t. I think so. Let's start. So you have Laplace of exponential 40, which will give me what? 1 over s minus 4, and Laplace of sin t should give me what? 1 over s squared minus 1. Are we together?
Yes, sir.
Then 3 Laplace of 3 Laplace of exponential 40 sin t is written as 3 open bracket 1 over s minus 4 all squared minus 1. 3 over s minus 4 minus 1. Are we together?
Yes, sir.
And number 4. No, number 4 is now when I start having cocktail. So Laplace of 3 exponential 2t sin 2t minus 4 over 3 minus 4t 2t squared. So for me, first thing is that you can split both of them to 2 to give you 3 Laplace of what? Exponential 2t sin 2t minus 2 times 4 will give me 8 over 3 Laplace of exponential minus 4t dot t squared. Are we together? Now for me, Laplace of exponential 2t will give me what? 1 over s minus Laplace of sin 2t. What will give me? 2 over s squared plus 4. Are we together?
Yes, sir.
And for that part, Laplace of minus 40 equals to, where do I have it? 1 over s plus 4. Then Laplace of t squared. That's going to give me what? 2 over s is about 3. So I can now see that the final answer, so the Laplace of 3 exponential 2t sin 2t minus 4 over 3 exponential minus 4t t squared. Are we getting it? Okay, 8 here. So what do I have here as my final answer? I have 3. Okay, 3 open brackets 2 over x minus 2 squared plus 4 minus 8 over 3 open brackets. That will be what? 2 over s plus 4 all cubed. So from here your final answer can now be what? 6 over s minus 2 squared plus 4 minus 16 over 3 s plus 4. Algorithm. It's fine, boy. That's the side beside you. As even you, safe. I'm just seeing you. There's a wallet, Jojo. Oh my god. Ish, yo. Why is he caught a tongue or Jambo? I'm a drug for Padalini money. So, by God's grace, we end this class, the same place we ended it with 3 and 5. So, and I will see it again. Anytime 3 and 5 tutorial will be held here. If you are doing 205 and you know, and you sit down in your house, it's who are you for you. And the reason is because I'll just continue both classes. I told you that both classes are the same thing now. I'll continue both classes. That's why I just pity you. I know if to say I saw yourself, I'm not pity themselves. Can we start, please? And number 5. How's writing? Okay, I should wait. I'm waiting then. There's something I want to say, but I will not say it. So let me hold the word till I finish. Used to be faster. So I don't think 205 students should be scared anymore again now. Abi now? Abi now? All the parts they did not treat in class, I think we've treated all the parts here. Abi now? Which parts did they treat? Have they not thought that we have not done here? We have not reached Laplace. Okay, you have not reached Laplace in your school. 315 have not reached Laplace. That's bonus for you now. Is it not good to know what? Is it not good to know ahead of the class? That whenever they are teaching them, it doesn't like play. Yeah, that's the operator method. I want to teach you together with variation of parameters. Those two. I'm waiting now. Make we go. If you are done, just tell me so that we can start. If I can continue like this, and probably 84 self might not even be scary. Ah, sorry, bro. The thought I have gone before, but God not allowed for them. Have you know? I want to learn how to play that day. We go, we come. Have you know? Yes, at first, please, I beg, answer me. We go, we come. If you are done, let me know. Be quick, be quick, be quick. Sure. Starting? I told you to tell me now when you want to start. And stop looking at me like crazy boost. Fine. Number 5 is what? A pass of let's go. 50 squared. Okay. You can bring your 2's outside, maybe. So with 2 Laplace of t squared exponential minus 3t minus 4 Laplace of 2t plus 7t. And from here, I have 2 or Laplace of t squared equals to what? 2 over s cubed Laplace of exponential minus 3t equals to 1 over s plus 3, yes, with minus 3 s plus 3, okay, and Laplace of exponential 2t cos, 2t cos 70 now. So then what I have here? Laplace of, okay, let me take it here. I have exponential 2t here. What would that give me? 1 over 2 minus s minus 2 and Laplace of cos 70. So what would that give me? S squared plus 9. Okay. And I can answer that the answer here. Laplace of 2t squared exponential minus 3t minus 4 exponential 2t cos 7t. At the end of the day, everything here should give me what? 2 open brackets 2 over s plus 3 all cube close bracket minus 4 open another bracket s minus 2 over s minus 2 plus 9. And at the end of the day, your answer should now be 4 over s plus the cube minus 4 minus 2 s minus 2 squared plus 49. Thank you. Number 6, have you? Now let's look at number 6. Can we just move faster than all these steppings? So Laplace of what do I have? 2 3t cos t plus 20 t squared divided to t. So what is exponential? Laplace of exponential 3t as what 1 over s minus 3 and Laplace of course cos t as and Laplace of t squared. Then from here, what do I have? I have 2 open Jesus Christ. 2 open brackets. 2, wait, it's also. So 2 over, that's s minus 3 over s squared plus 1 plus 20 2 over minus 2 all cubed 2 s minus 3 s minus 3 squared plus so number 7. So Laplace of 2 sine t initial 3t plus 4 cos 2t and minus 3t. Let's start speaking. So Laplace of sine t, what Laplace of sine t give me? 1 over s squared plus 1. Laplace of exponential 3t. I give what 1 over, I must say, Laplace of cos 2t. That's s squared plus 4. And Laplace of exponential not 2t. So that gives 1 over s plus 2. Okay. Where should I want to fix it somewhere? I'm just putting everything down here. My final answer here will now be what? 2. Now open bracket. So that's where's sine t? So I have 1 over s minus 3 all squared plus 1 plus 4 bracket s plus 2 over s plus 2 squared plus 4. And the answer here is what? 2 over s minus 3 squared plus 1 plus 4 s plus 2 over s. What's up? Ọmọ bó ṣe ń ṣe é. Shifting theorem 2. There's one friend of mine that's in Sunday 11. Oh, she's not come today again. Let's start solving. Hmm? Are we?
Yes, sir.
Let me explain how you use shifting theorem 2 for him. One thing low, car. Yes, sir. Car. Right, let me explain how you use exponential 2t. I mean, shifting theorem 2 for you. I watch shifting theorem 2. I watch shifting theorem 1. What shifting theorem 1? How do you know it? As mentioned by exponential at or what? Exponential minus at. And this time, shifting theorem 2, how do you know it? It's a multiplication of function of t with any other type of function. And this time around, it is unlike the first one, which is easy. The t here, in this sense, you are not necessarily integrating or differentiating. You are not even finding the Laplace of the t self, as far as the t is concerned. Do you know the only thing you do to the t? Now, the only thing that t stands for is that the power on the t tells you how many times you differentiate the Laplace of the second function that joins with the t. You get an apparently like that. What I'm trying to say is that, you know that here you have t, like unlike before, that your exponential, you don't substitute. This time you are not substituting. The power on top of t will tell you how many times you differentiate the second Laplace that is given together with that t. So for example, if they give you t squared exponential minus 2t, first of all, look for the Laplace of what? Exponential minus 2t. Now, how many times, what is the power of your t there? Squared. That means that you are differentiating your Laplace of exponential minus 2t, how many times? Twice. After you have differentiated twice, you can now plug it back inside that equation. It looks simple, but at the same time, very, very long and deadly. Imagine having a t cube or t4. Even if there's no simple function here, sir. I know that there's only one man that is capable of that thing. I pray it doesn't do like that. Already, so let's start. Number 1. So what do I have? Laplace of what? 2t squared exponential 2t. I told you the only thing I need is what? Laplace of what? Exponential 2t. And what is the Laplace of exponential 2t? That's what? 1 over s minus 2. Yes or no?
Yes, sir.
So which can also be written, Laplace of exponential 2t can also be written as s minus 2 is by what? Minus 1. Yes or no?
Yes, sir.
So now let's go. d ds of s minus 2 is by minus 1 will give me minus s minus 2 is by minus 2. Yes or no?
Yes, sir.
And d square s, no, d squared ds squared of s minus 2 equals to what? 2s minus 2 which was minus 3. Yes or no?
Yes, sir.
Then here on the long run we're gonna have 2 out together. Now bring it inside this bracket. You have what? Minus 1. What is the power of your n here? 2. Are we getting it? Then you have d squared over ds squared of what? 1 over exponential that is 1 over s minus 2. Are we getting it? Your final answer is going to be 2, everything here, 2 s minus 2 is by what? Minus 3. Yes or no? Your final answer is what? 4 over what? S minus 2 is by what? 3. Look as if, yes. You don't get. I told you that whenever you're multiplying with t, whenever you're multiplying with t, the thing that you just do is that exclude the t. You don't have any business to do with the t. Now, the only thing that I don't know why you don't have business to do with it, but that's what the law states. If you want to know why, go and ask the person who created the law. Don't ask me. I don't know why. My own is just to show you how it can be used. Now, the thing is that the only business you have to do with is what? The exponential what? The other function that is joined together with what? With the t. I get one approach like that. Then after that, just isolate that function. Find the Laplace of that function. And after you have done that, the power on top of the t will tell you how many times you will what? Differentiate the Laplace of the other function. See, I had t squared here. Laplace of this one was this. Now what was the power of this t here? 2. It means that I will differentiate the Laplace of this one how many times? Twice. That's why I decided to differentiate it here twice to give me this answer. Maybe now, by differentiation. Then after I've done this, then it is now my goal to return my answer back inside this formula. So this is the formula for the second one. After I've gotten here, then let's now go. So I can now have here, this 2 here is from the 2 that is outside. Then what do I have? Minus 1 raised to the power n, where my n is what? My power of t. I'm getting?
Yes, sir.
Then this one, dn over dsn. That is, how many things do I have here? I have 2. D squared over what? ds squared, or the Laplace fraction of the other side. And I've done that one, which gave me this. Abi? Then open your bracket, and you have this. If you don't get this one, you get the next one. That's why I did how many examples here? 7 examples. Cannot run through all the 7 examples without knowing it. Let's look at number 2 again. Number 2 example. In number 2 example, you have what is Laplace of 4t sine t. Good. Now, as I thought, isolate this one, which is Laplace of sine t. So if you isolate, yes? So if you isolate, what is Laplace of sine t? That's 1 over s squared plus what? Plus 1. Are we together?
Yes, sir.
That's Laplace of sine t. So since this is Laplace of sine t, now what is the power of t that is here? 1. How many times should I differentiate this function? Once. I can now have what? d ds of what? 1 over s squared plus 1. And I hope that this answer here will give me what? Minus 2s over s squared plus 1 all squared. Abi?
Yes, sir.
Then for me, as soon as I've gotten this now, put this answer back inside the original question. You can now say that Laplace of 4t sine t equals to 4 open big bracket. What's there? Minus 1 raised to power. What's the power of n here? 1. Then d ds of, now what was that one here? 1 over sine squared plus 1. And here I can have what? Minus 4 open bracket. What is d ds of this one? Minus 2s over s squared plus 1 all squared. And then the answer will now be what? 8s over s squared plus 1 all squared. Did we get? Can I clean the other side? Continue. And let's look at number 3. What is number 3? The Laplace of 2t squared cos. Is it cos?
Yes, sir.
Cos. Away. Wait. What is cos? What is in cos? Away. from here, let's go. Laplace of what? Cos 80. So what would that give me? S over S squared plus A squared. Are we together? Which can also be written as S squared plus A squared minus 2. Now, how many times am I differentiating? Sorry, minus 1. Because of this one, I'm differentiating how many times? Twice. Let's go. ds of what? Of S over S squared plus A squared. So what that gives me here? This is product through Abi minus product through minus 2S squared open bracket S squared plus A squared minus 2 plus S squared plus A squared raised by what? Minus 1. Yes or no? Yes or no? Yeah, let's see. Huh? It's correct, Abby? Good. Now, so from here, now what do I go again? The square, the S squared of what? S over what? S squared plus what? A squared. And what would this one give me here? Now this is another product too. What will I have here? That is, it's not going to be 4 now. It should be 8s cubed. Yes or no? Yes or no? 8s cubed, open bracket, S squared plus A squared is by what? Minus 3 plus this. I have 4s. I mean now, is it 4s? Minus 4s, open bracket, S squared plus A squared raised by what? Minus 2. Are we together? Then this will give me what? Minus 2s S squared plus A squared raised by minus 2. Okay, I'm done. I can now say that the Laplace of what? 2t squared cos 8t. And I give you what? 2 open big bracket minus 1 over n the square over the S squared of S over what? S squared plus A squared. Are we together? So that will give me what? 2 open bracket. This one will go because minus 1 all squared will leave. So I now have 8s cubed over S squared plus A squared with all cubed minus 4s over S squared plus A squared all squared. Are we together? Minus 2s over S squared plus A squared all squared. If my answer like this, it's better this way. Are we getting it, please? Yes, sir. Let me give you time to write. Yeah, let me give you time to write. Sure. I love it that I say that my girls. Don't worry, after I finish, I'll come and get him one by one. And there are some girls that see that my girls that have not seen me before in my life. You've never seen me before. Alright, I'll give you time to write quickly. Yes, sir. Yes, sir. Oh, okay. That one is a two-way system. You can any of those you can use t and exponential to get the same answer. Yes. I didn't even notice if This one here. The one up. Okay, I differentiate it. Then the power on top will come to the front. Product through first. Then S. Then you differentiate the S inside, which will be 2x. 2s multiplied by the s outside. Very good. Let me see. I'm shivering now. I did that just now. Wish kumali la lele. It's supposed to be. One of now, but does they drop like popo? If I see anybody that is sleeping here, auntie, sorry, sit down where? Let me see your face. Sorry. I've tried. So can we clap for her, please? I'm serious. I'm telling you, I've tried. You have tried. Some people are in their bed now. On the falala. I hate that thing, man. I don't write in, please. Okay. What's the writing? It's good to be ritual. I'm telling you. So, with this class, we need to go to 315. Hey, So what's your name, my friend? My friend has a name says that is running. What's your name? Okay. I just what's your name? Hey, why? Yeah. I'm wait for le. Which one is next to? I quickly know. Which one is next to? I know. Which one is next to? Which one is next to? Are we done writing? Are you sure? I'm hearing no, and I know it's more than the yes. Yeah, please write fast, please. Should we start at 61? We started at 61 now. 61, 62, 64. I mean, do fast though. I don't know. I don't want to rush you. Do fast, huh? We start at 64. We started at 61. I mean, every time I become used to use the tissue. Right through this marker in your face. This is. Tissue 1 to 3. Why are you doing like baby now? Which one? Which one is next? 2-1. We're flowing our flow again. Abina. Oh yeah, now fine boy, I'm with you. Yes sir. Eh, it's too small. No, no, yes, I understand your point of view. Yes, yeah, yeah, you are fair on that point. Yes, you are very, very fair on that point. And let me leave that. Let me leave that to your discretion. No, you are doing tutorial now, so you can't expect me to be. Well, I can, but it should just become more of notes for you. For example, if I now start showing them that differentiation, and whatever trick I did there, I did it fast. I still did short courses. Some people are not done writing. Don't talk of when I'm not doing the long courses. But in exam, don't worry, feel free, express yourself. But whenever you're expressing yourself, don't forget that there's time. As you're expressing yourself, be expressing yourself in time. Wait, after 2 more, which one? Wait, I will be all for you. We. Yeah, Koshaki, are you done? Are you done? Okay. Yeah. Number kí mo ṣe ṣe? Number 3 ìwé àdẹ̀ṣe lọ 7. Ọ̀tún àkà. So number 4. So what's number 4 now? Okay, Laplace of t sin at. As I've said, what? So Laplace of what? Sin at. So what would that give me? Over s squared minus a squared. Okay. Then d ds of a over s squared minus a squared give you minus 2s a over s squared minus a squared all squared. How we take it up? I can answer that. Laplace of what? T sin at. That give me what? Open bracket minus 1 is power n. So this by 1 and ds of what? A over s squared minus a squared, which will give me minus 2as over s squared minus a squared all squared, and the final answer is what? 2as over s squared minus a squared all squared. Number 5. We number 5 Laplace of 2t squared minus t minus 2t plus t. So, okay, good. Thank you. So I think from yeah. So from here, where should we continue from? Okay, I've done this part, right? Let's continue on this part. So from here, I'll have Laplace of what is it? Cosh t, and Laplace of cosh t is giving me what? S over what? S squared minus what? A squared. I think I've differentiated cosh here now. Have I? No. So now d ds of s over s squared minus a squared. What should that give me? Minus. Wait, it's still the same thing as that one. So let me come down here. So d ds open bracket of what's the other part? Okay, I want to differentiate s over what? S squared minus a squared. So I think the answer should give me minus 2s squared s squared plus a squared plus s squared plus, it should be plus now, it should be minus a squared is by minus 1. Abi now? Then here I can now find Laplace of 4t exponential minus 2t plus what? 2t cosh t. Are we together? Then what would this one give me? 4 open bracket minus 1. So if I use this to expand this one, minus 1, this one 1, d ds of 1 over s plus 2, then plus 2 minus 1 dds and from here we have 4 over s plus 2 plus minus 2 plus 4 s squared yeah, write quickly. Abi, I don't write any. Write quickly. Oh yeah now. I just saw me. I want already. Billy, fine boy. Billy. Oh yeah now. Ah, you don't delay me. Oh. Ah, how done? Number 7. Have you done number 7?
No.
Let's go. Yeah, yeah. See, do you know what? I don't know how we'll be doing it. We'll be writing fast. I have 58 minutes, and I must carry you to where I carry 3152. I carry you to where you don't know. Next time you will know it. Are we together? I want to clean everything on this part too. Practice, go and practice number 7 at home yourself. I have to go and do shifting theorem 3. How many examples so far? Hmm? 18. We 23 for today alone. It's not a bad thing. Is it bad? I be on to do more. La 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 la. I don't even care whether it's robot that is going, it's just going on his own. Yes, sir. I tell you that someone that works on the body. Just, yeah, the last one, shifting theorem, number 3, dividing by t. Let's do the one we did in class that time. Call it for me. The one we did in class. Let me carry a question now. Let's do 2. Let me check. Let me check. Give me your phone, let me check. Can you? If you have cash out, I advance in math. I have one sense. God bless my dear. Let's be coming down. You don't use your phone today now. Are you still new still? I haven't started. I don't bother me. Yeah. I'm gonna teach me. I'll not be bothered. Okay, let's start one more. Let's anxious. Anyway. Penny. Are you doing that? Yeah, okay. For this third one, you will calm down very well. That's why I'm waiting for you guys to finish that all of you can be on the same page. When you calm down very well, like you don't understand. After calming down, you not calm down. She gets. After calming down, you not calm down, but you must not sleep. So now this is, first of all, whenever you have anything divided by t, first thing you have to do first is that, whenever I have anything divided by t, first thing you have to do first is that find the Laplace of your numerator first. For example, number 1, the Laplace of what do I have? 1 minus cos 2t. Have you now? Now, what is Laplace? That will give me 1 over s minus, what is cos 2t first? S over what? S squared plus 4. Are we together? And after I have got this, the next thing you have to do is what? Input this one inside this integral. Then you can now have from here infinity sigma equals to s 1 over sigma minus sigma over sigma squared plus 4. This sigma. Then if you integrate everything here, you have 1 over, you have ln sigma minus 1 over 2 ln sigma plus 4 divided by infinity and what? And 0. And this is not 0. Then from by here, once I've gotten to this place, if I put infinity here, everything will vanish. Minus. So that minus can open this bracket and change it to plus. This one will be plus, this one will be minus. Then put sigma. The final answer can be what? 1 over 2 ln s squared plus 4 minus ln s. Yeah. Integrate on top is what you have. You have integrated this one. Change every s to sigma and put it it inside this integration. Then integrate it normally. You have this. Then there's infinity here. Infinity, if you put anything here, infinity will cancel it now. B. Then minus. That's upper bound minus lower bound. The upper bound of everything is what? 0 minus the lower bound, which is putting s. That minus can now open this bracket to bring this one to the front, take this one to the back. Okay. Oh. What's number 2? So Laplace of what? Measure 3t minus 1. Or if you take this one, what's Laplace of? That will give me 1 over s minus 3 minus 1 over s. Have sigma infinity. Then sigma equals to s 1 over 3 minus 1 over sigma is sigma. And here you now have ln of sigma minus 3 minus ln sigma infinity and sigma equals to s. You have ln then s minus then s minus 3. Plus of what? Sinus 2t. What are plus of sinus 2t? That's 2 over. I think we have to. So for me to integrate this first, I'll have to use integration by partial fraction. I bet you say the answer straight up. Let's find it. Yeah, how? If I can get partial fraction. Are you ready?
Yes, sir.
So do fast. Be here. So here I can now have so over sigma squared minus 4 the sigma. Can someone also help me with this sigma minus 4 the partial fraction thingy? Partial fraction there. This will give you sigma s 1 over 2 1 over sigma plus 2 minus minus 1 over 2 1 over sigma plus 2. This sigma from here you have 1 over 2 million sigma minus 2 plus 1 over 2 million sigma plus 2. Infinity and sigma equals s. And answer 1 over 2 million s plus 2 1. Okay. Well, that will be that about that for that thing. This is 7, 8, 9, 10. 7, 7, 8, 9, 10, 11, 12, 56, 7, 8, 9, 10, 11, 12, 13. Give me a book. Not the book, the book. Let me show examples. The examples. I'm going to show a book. This is my department. Have you seen my handwriting before? May I play my phone? Yeah. We yes, sir. As morning we no go. Hey, wait. What is your muscle? Now, I want to look at the inverse of this. Don't call it team. I'm a Burso Gijo. Sorry, boss. Sorry, you saw me going on, man. Sorry. Stand listen. Who's that leg? I'm going to sit down way. So now, I want to find the inverse of Laplace transforms. And the other ones we did before were we moved from questions to answer. Yes or no? At least I want to move back from answers to what? To questions. Yes or no? And here, it has only one simple trick for you to understand. And the trick is what? By looking at the denominator of that fraction you are wanting to solve. That is the only way you can know which is which. So if you want to start looking for numerator idea, you'll be confused. I get my branch like that. So if you want to know how to look for inverse Laplace transform, try observing the denominators of everything you have there. Their denominators might look a little bit similar, but they are always different and unique from each other. Now let's look at number 1 now. What is the denominator of number 1? You have s squared minus 16. So first of all, you should know that there was a plus. That is, there was an s squared minus 4 squared there before. Abi now? There was an s squared minus 4 squared before, and the 4 squared became 16. And so let's go and look which one can have s squared minus a squared in the denominator. Yeah, it should have been Sanch. If to say there was no a, but now what do you see there? There was s. You get things like that. So with that, because of that, I can say that number 1 is 4. Look on you now. Focus 40. Number 2. Yeah, let's look at number 2. So number 2, it's obvious that there's a 7 that is disturbing that piece there. So remove the 7. Then you have s over s squared plus 2 squared. That's cos. Number 3. So now, look at it. You have what do you have there? S raised to the power 3. And that's obviously a t. But how can you know? But if you have s raised to the power 3, it goes from what? S raised to the power what? 2 plus 1. So everything will be what? 2. Yes or no? But here is 6. So definitely there's a multiplication of what? 3 here. So can I give us 3t squared? Number 4. I have s 3 plus 1. Everything here divided by 3 factorial, which is what? 6. And instead of 6, there are 3 there. That's multiplication of half. Number 5 can go. So that's it. That's exponential 2t. Number 6 is 4. Number 7. S squared minus 25. That's s plus. That's cos 5t. Yeah. Let the man inside s squared minus 3 squared. Pẹ̀lú That's going to give us 4 sin 3t. That's how it is. Should grab.
Yes, sir.
You have to elongate the method yourself. It doesn't really have a long method of solving. Yeah, quickly write. Don't clap kankan. Ọdún sún tuntun pàtẹ́wọ́. Okay, it's not sign. I'll put TDA in your notes. I want to give you guys. I want to give you. Now there is. I want to drop a classwork for. I want to give you a 5 minutes classwork now. And I'll be back to my check it now, like now. I'll find the Laplace transform of this. Now. Ah, you're not through with this one since morning. Ah,
We are done.
you're done. I intentionally wrote it in a way that will confuse you. I just looking at the back. Wait, how many? Hi. Yeah, now. This one. Ah. That one's only first theorem. I do and tell me answer.
S minus 1 K minus 1.
Eh?
S minus 2 is 1.
What did you say? If you are done with this thing on the borders of your hand, you did it. Even if you don't know the answer, say, but you did it of your hand. Very simple now. It's because of the way I wrote it. Eh? It's because of the way I wrote it. How will you have done here? Open your bracket. And with this, you have 1 over s plus what? S minus 2 minus. This one is squared. That's 2 over s cubed. So 1 over s minus 2 cubed. Eh? Eh?
There will be 2 on top.
Top which one?
Like factorial.
Okay, yeah, so factor, thank you. That's funny. Shish. Shimo. Huh? Eh? Jest mi się tutti, no? So, how to find inverse Laplace using partial fraction. Let me clean up that side too. This is at Nipanji, Wika. That one that pull head, can't tell her to pull her head up. Is it he or she? Tell us. Bruno, you can yell like. Sorry, yeah. Sorry, yeah, sit down where. Can we move?
Yes, sir.
Let's move. Now let's isolate the partial fraction here. We have 4s minus 5 divided by s squared minus s minus 2. Then I think this one here can be factorized to give you 4s minus 5 over and s minus 2 s plus 1. And since you have this, it's equivalent to saying you have a over what? S minus 2. Abi now? Then plus b over s plus 1. Abi now? I can now say that your 4s minus 5 is equal to what? S squared minus s minus 2. Yes or no? Is equals to a over s plus 1 plus b over s minus 2 over s minus 2 s plus 1. And I say 4s minus 5 equals to a open bracket s plus 1 plus b s minus 2. Then like let s equals to 2. Then 4 open bracket 2 minus 5 equals to a open bracket 3. Yes or no? What times 2 is 8? This is 3, Abi? 3a, and you can say that a is equals to what? 1. Let s equals to minus 1. Altogether. Now what do I have? 4 bracket minus 1 minus 5 equals to b, which equals to minus 3. So minus 1 minus 5 is equals to minus 9 equals to minus 3b. And b is equals to what? 3. So therefore 4s minus 5 s squared minus s minus 2 equivalent to, what is the a? 1 over s minus 2 plus b over s 3. After this, plus inverse of 1 over s minus 2 and plus inverse of 1 over s minus 2 what this one give you? Abi now? S right, Daddy. A over s plus 3 plus bx plus c plus 1. Oh yeah. I would get that. Hmm? Hmm? 5 times 9 is 45. 45 minus 40. 5 times 9 is 45. 45 minus 40 is what? 45 minus 40. 45 minus 40. Ah, cow. 5 minus 1 is what? 4. Goes to A. 3 square is 9. That's 10A. Abi? And A is equals to what? Wait. It's 3. 45 minus 24. 45 minus 24. Tani. Ha. I Koramo. This one give you 2. Are we together? Open your bracket. 5s squared plus what? 8s minus 1 equals to what? as squared plus a plus bs squared plus 3bs cs plus 3. So from here, by comparing, I can say that 5 is equals to a plus b. Then here, 5 equals to what? 2 plus b, and b is equals to what? 3. Comparing with s, b plus c is equals to what? 8. This is going to be 3 plus c is equals to what? 8. Abi now? Then from here, c is equals to 5. Abi? Okay, there's a 3 to it, sorry. That's going to be 9. And c is minus 1. Okay. Then which one am I looking for? I have A, I have B, I have C. Yes or no? So from here, I don't know how it's doing usually. 5 s squared plus 8s minus 1 over s plus 3 s squared plus 1 equivalent to, where's my A? 2 over s plus 3 plus, what's B? as 1 over s squared plus 1. Then we can say that the inverse Laplace of 5s squared plus 8s minus 1 s plus 3 s squared plus 1 Laplace minus inverse of 2 over Laplace inverse of 3s over s squared. Always get that. Ew. Minus Laplace inverse of 1 over s squared plus 1. This one can give me what? 2 exponential minus 20, then plus what? 3 equals t minus sine t. Yeah. I'll not write it if I check it. Yeah, finish writing. Wow. Cool. Awesome. Why? Yeah. I was deeply. Wait. I don't know if any of us have used phone that backup is not strong. When it now gets about like 5%, I use that 5% to watch movie of 2 hours. And after the phone dies, you on it again, it picks up about 3%. And that 3% again, so that's my state now. So anyway, let's try it, please. I didn't you one now, Abby? I don't know one person is answering. I will tell you the criteria. If you sleep for 5, if you sleep for 2 seconds, and I catch you, you stand up for the rest of the class. You come and join my ministry. Now, come and join my ministry. But I want us to make this time. I will do writing, please. So I think, please, I think there are some other exercises I did. I think I did one again before I left the class at that time, for 3:05 in the afternoon. I did not do 3 more. It was only 1 more I did. I made it 3. I should hope to actually complete the rest in Naomi. So the next time we'll be meeting, I think I'll balance it like that. So the next time we'll be meeting, we'll just be entering straight to how to use Laplace to solve what day. Sorry, yeah? I know it's not easy. I made that sleeping now, but I cannot sleep. I don't sleep for the weekend. What are we talking about? What are we talking about? What call him? I can't say sweet if you have. What are we talking about? I'll come and I'll see. Okay, what I'll do, I'll put it in my mind. Let's say I don't go outside, I don't come back. Give me. The big. But next time, as I said, we'll be meeting. We'll be discussing how to use Laplace to do with D. That's number 1. And we discuss how to use Laplace to do simultaneous equation. Yeah, there's some simultaneous equation that requires you use Laplace to solve. Then after that, I think we should have exhausted Laplace if we can do that 2 parts. And after that, the next time will now be PDE. See that you are moving faster than you thought. Hmm? How can I apply to real life? And you reach real life first. And we get real life now. Yes, yeah. Most of these things are in medical lines. All these Laplace them, Fourier transforms them. I do again. That version of parameters, if I get material, I will. If you have any materials, personally, give it. I just need to digest it. I have not seen the ones I don't know. Jumping. Anyway, take a shot. Anyway. Yes, that reminds me. Let me just be saying things. Let me just be saying tips then. Let's have 5 minutes to let me say in tips. So as we have proved Laplace, please try as much as possible to make sure that you can use Laplace to prove some fundamental theorems. For example, I don't know. God might be, and it might be a part of your question that they ask you to just verify. They will ask you to show that the Laplace of sin 80 equals to this. And when they ask you to show that, they ask you to solve using what? Laplace integrals. Just practice. I think this one I did how many? I did 4 now. Is it 4 or 5? I did 4. I think you Jamie setting. So oh my. And again, for textbooks that you will use, don't bet it's too simple, but you can use it here to build your foundation. You can use Advanced Engineering Mathematics by K. Stroud. It's not the ordinary engineering. Wait, is it 4? What's his time? 4. 4. Okay. Why are you clapping now? I don't understand. Maybe I just ask time, money. You never know that for a snack. So I'm waiting for those of us that are writing. So I'm still on 305. We're going to download Advanced Engineering Math by K. Stroud. It has this reddish display on top like this. It's about 57 MB on Google. Yes, it's 57 to be precise. I think some 57 and some KBs. So if you just go online now, like if I was your phone now, just go online and type K. Stroud Advanced Engineering Math download. You drop a link for you, then you click it. You walk link download. You get it. Or better still, you can use what's his name? You can use HK dash. This is a typical example of HK dash. This one. I don't know how much it weighs. Is this thing heavy or is it me that is weak? Wow. It's heavy. I like myself like this. That's what I dropped there. I don't know how much you can buy it hard copy. You can download the PDF. I want thing about PDF. You don't literally. It saves you cost of expenses. Money you can use to buy one textbook can be enough to download the library. I don't know. So that's how it is. I've told you we are entering into another class now. If you sleep, you stand up. I promise you. Stand up 5 minutes, and you don't stand up anyhow. You stand up on your chair. So if that evil spirit of sleep is still in you, that oh God, some of you jabber the chance. So now, let me clean the board. Thank you very much for this 2-5 class. I'll see you again. So, 2-1. I've told you, see, you don't want to sleep in 2-1, don't come. So this, yes, I think we met yesterday now. Yes, we met yesterday, around yesterday evening, stroke night. I've been now. It's the 7. Hey, we. Hmm? So at the end of this class, we should be able to at the end of this class, we should be able to attempt any, probably any multiple integration question I will see. That's the goal. That's what we are going towards. That means we have a lot of examples. We have lots of examples that we'll solve together. So I think after multiple integration, what else do I have again in 2-1? Before we round it up. Line integrals. Wow, that's very fast. Eh? What? That one. Yeah, readable. Read them and you pass. Now the first thing here. For multiple integration, there are like two types. We have the double integral. Double integral is when you have something like this. Listen now. I have not seen anything. What if actor wound? If actor not can die. Actor can wound now. No matter motivation, we should work. I want to get now. Now listen, look up. Now there are two ways to evaluate a double integral. Please look up. Very, very important. Look up. Sorry, sister. Look up. Come back. I know it's not easy. Sorry. Now the first way is to let me sketch the diagram for you. First way is to move from inside and you what? And you go outside. Yes or no?
Yes,
That's one way. And the second way is to what? To move from outside to what? To come inside. For example, now this is. Sorry. Can I? Okay. Let me do it like this. Let's start. Only go, please. This question has helped us in a way by splitting it into two. Are we now? So now, yeah, want to integrate. So where do I start my integration from? I start from this one in front. So if I isolate that, I have x0 exponential of what? Y x minus 1 dy. Yes or no?
yes, sir.
Then from here, anytime I want to integrate the exponential, I would write about 1 over, I'll be now, then integrate. So if I differentiate this on respect to y, what do I have here? X minus 1, and exponential what? Y over x, bounded by what? X and 0. Are we together? Then from here, what do I have? 1 over x is what? X multiplied by exponential y comma what? Y over x, then everything gives me what? X and what? 0. Since I integrated with respect to y here, then I will be expected to change my square from y back to what? To x. And from here, I can now say that I'll have x multiplied by exponential x over x minus x exponential x over what? No? It shouldn't be exponential x. Exponential 0 over what? Over x. Are you getting it, please? Good. Then from here, what will I have? Is that you have x exponential what? Exponential 1 or minus x. Are you getting exponential 0? Is that now become what? X exponential minus what? X. I get one apprentice. So everything that I have here will now be what will be transferred. The second integral, which is going to be integral 1 0. Then I have what? X exponential minus x. Everything is what? Dx. Then exponential here is a constant. I be now. And I can have x squared exponential over x minus what? No, over 2 minus x squared over what? 2. Bottled up with what? 1 and 0. I think 0 here will leave out. Yes? The final answer will now be what? You put 1, yes. 1 over 2 exponential minus 1 over 2. I be now. Yeah, I like that. Are we done writing? Another example. Wait, this interview. Now, okay. Another way that I can help you on this one is knowing which of them to integrate first. That's another one. That's another one that can help you. Knowing which of them to what? To integrate first. And so from this place now, how do you know which one to integrate first? What you have on top of your closest integral here will tell you which one you want to integrate. I hope you know that here, when I integrated here first, when I integrated with respect to y, I integrated y so that I can substitute what? X in it. It wasn't that if I integrated x so that I can substitute x. Are you getting my point like that? Now here, what are you having here? You're having what? X. So what are you integrating? You're integrating y first. Then take this one. So you can move this one to give you integration of 2a0 dx. And now integrate, what is this one? S squared over 4a0. Now have what? Xy dy. Then by isolating that one, x squared over 4a0, you can have xy dy. Are we together? So by isolating with respect to y, you can have what? Xy squared over 2. Yes or no? And bounded by what? X squared over 4a, or you die. Are we together? Most of them will not choose x multiplied by x squared over 4a all squared, but what? Mostly. I will get something, please. From here, what do I have? I have x multiplied by x is power 4 over what? Over 8 a squared. So I think this one now help to give you x is power 5 over 8 a squared. How together? How together?
Yes, sir.
And from this part here, you can now have equation of what? 2a and what? 0. So instead of it, what will you now have there? I have x to the power 5 over what? 2a. I will know. 2a is what? 8a. Then what do I have here? dx. Abi? This one is a constant, so I have 1 over 8a squared out. If I have 5, I have 1 over 8a squared. This is power 6 over 6. I get to me? 2a and 0. And I have x6 over 48a squared. Bracket by what? 2a. Have you now? Now I have 2a over 6 over what? 48a squared. And 2 6 power 6 is what? 6 power 6 is what? 6 power 6 is 64. A squared. Then what's common now? 16 in this. This is now give me what? 4 over 3 a raised by what? 4. What is that? What do we do here? What does it now become? Please have a look at this one. What would this one be? I've indicated this one over 6. To put a inside this place, inside x. What do you have? 2a raised power 6, have you? Have you now? And what is 2a raised power 6? Eh? 2 raised power 6 is what? 64. Have you? So with this, what do I integrate first? Is this kind of snare, what do I integrate first? That's what I integrate first. Then I can carry dx in the second one. I have integral 1, 0. I will take that. Then isolate this. Please. Please, please. All eyes on board. Hope I get what I'm doing, please. I get what I'm doing, please. So from here. If I open this one squared. Nice. má tẹ̀lé sùn tẹ́ ti jí tán ń pàtẹ́wọ́. Because I hope we are seeing a pattern to what I'm doing, please. I'm not just doing it for doing sake, because I told you that before you can know which one of them, you have to differentiate. You have to integrate first. You have to check the boundary of what of your first integral. So it's the boundary of your first integral that will tell us which one to integrate with respect to. How good when I'm trying to say like that? Please. Have you now? Okay, I will show. No more errors or problems or questions. Any of those ones I've said. Hmm? Okay. Where's batteries? Yeah, don't change it out. Yeah. Yeah. Which of this one am I integrating first? Hmm? Hmm? Which one am I integrating first? The y is what I'm integrating first, please. So from here, isolate that one. So I have x squared 0 exponential y over x dy all together. And if I integrate this, I will have 1 over x exponential y over x. This is x squared and 0. And this one here is now what? X multiplied by exponential. I should that takes x squared or x or is cubed. This is x exponential 0 over x. From here, I have x multiplied by exponential what? Exponential x. Yeah, I'll do this one. Have you now? I'm not sure this question now. Hmm? Uh, uh, put the integration by parts. Which one am I differentiating first? Huh? Try my differentiation first. Hmm? That's why dx now. I cannot differentiate dy and still put y inside. I personally did not learn that part. Yeah. No, like it's two ways. Either you do it going outside or going inside. Anywhere you want. You get your answer. Mm. Mm. How? Upper bound minus lower bound. How come that Nancy gets him to? Oh. This is empty. I get all of minus x here. Then this one here. These two cancel each other. No, they can't. Hmm? Yeah. Yeah. This is the strangest coincidence I've ever seen. Yeah, this one. Look up. Masih tambah question ni sama malan ha. Oh, denule. Wake everybody is sleeping, Joe. I know you tried. I know. Ah, we are sleeping. I said, "Be a human being that is in front that is not sleeping." Ah, I'm not robots now. But I think what don't part of here and you don't part of what here. Let's continue, please. These things are very, very important. This man, I was not supposed not to stress myself. I'll do as many examples as you can do so that by the time you start seeing them in your test or exam, you'll be able to attempt them. No, I'm an attempt there. That's one thing about constant practice. Constant practice, no matter, even if you are not practicing with the right material, you are practicing with something similar. You will meet any day you meet the right material, you will do something. It might not be much, but you will do something that will even shock you yourself. I'm serious now. Then that number 7, which one am I to get in respect to? dx. But do you know that in that dx I don't have any x there? Good. How do we go about that? Have you now? So if I integrate dx, what would I have automatically? X 100 by what? Have you? Here, what should I give you? How do I differentiate? How do I integrate? How do I integrate this one now? Hmm? Substitution. I thought if you thought talking now. Mm-hmm. Can't work like that. Yo. Wait. Square root minus uh, if you jump it here, they're coming from jump it. We bring it down. Is that the time to put it in? Hmm? My boy. Is that the time to put it in? So far the current one is doing. Hmm? Yeah. I'm waiting for a response, so I'll find a way to. I'm waiting now. If I have something like this, use trig substitution. But the problem is that the thing that it does this is just is this square? Good. So from here, bless me, Coco. A GG came out of we when this person will come. Please, I think we got it up to this part now. Let's see. Ready? I should just be doing my own. Anyone that will follow should follow, Abby. Okay, so no problem. No. No. Anyone that will follow. Put your phone. I'm checking on the So from here, if I differentiate, give me a cos theta now. So from here, we does substitution from here. This sign here, differentiate. Before it, I just assumed. I can't call it an assumption. It's like a method. Èèyàn tó wà lókè lélẹ̀ ẹ̀mí mímọ́ I dey greet you. So now dey upstairs with this. But I with me in the spirit. Thank you. Ẹ ṣé. Thank you, I love you all. Thank you. Emma, that about why she time discuss love for us. Mathathon, no? As I was saying, from this part here, it's just like a trigonometrical substitution. Anytime you have a form like this, you substitute x equals to a sine theta. Anytime, like a standard something. That's what I did there. So I cannot say that y equals to a sine theta. Then if I differentiate, this is what I will have. but I'm not done yet. From here, I can now move on here and say that I have integration. Now, you see that I remove my definite. I want to make it what? I want to make it indefinite first. And after that, I'll make it definite. So what do I have here? Square root of, what is this? That give me a squared minus what? A squared. What is this one? Sine squared theta. Multiplied by what? A cos theta. So a cos theta d theta. Are we together? Then from here, you can factor out a squared. And you have 1 minus sine squared theta. Divided by a cos theta d theta. Yes or no? Then from here, all of you, I think you know that this one will give you a, everything will give you what? Cos theta. I mean now, multiplied by a cos theta d theta. So you can now have a squared cos squared what? Theta d theta. Then you can now take this one outside your integral sign to give you a squared cos what? Cos squared theta d theta. All together. Then I think if you can remember that cos 2 theta equals to 2 cos squared theta minus 1. Then taking this one to the other side and dividing by 2, and say that this one is the same thing as saying a open bracket, taking that 1 to the other side and dividing by 2. That give me cos 2 theta plus 1 divided by 2 d theta. Yes or no? Then here you can now have a integration of what? Let me do cos 2 theta. But don't forget that it's over 2. So I can bring that to outside here. Then let me just do it once and for all. A over 2. If I integrate cos 2 theta, that will give me what? Divided by 1 over 2 sine 2 theta plus this 1 over 2 has come outside. No. I'll still have it plus theta be now. Plus theta. Then my final answer will now be what? A over 4 sine 2 theta plus theta. But my question was not in terms of theta. My question was in terms of what? Y. So from here, let's now make the substitution. Okay, let me come back here and say that we call that y equals to what? A sine theta. And for me to make, so I can now say that y over a is equals to what? That equals to sine theta. All together. And theta is equals to what? Sine inverse of what? Y over a. Let me bury it here. Are we together? Okay, why don't you ask? Okay, this place, I mean. How did I get to this place? Yes, this is squared. This way. Okay, yeah. Okay, this 1 minus sine squared theta. This one here. Okay, supposed to be a square. Sorry. Sorry, like that. I think it's balanced. Is it equals to cos square theta? Yes, I've taken the square root. So from here, this I think this is my answer now. When I solve this is my answer. So let's now start substituting. Can I have, what is this? A squared over 4 sine 2. What is my theta? Or Abi? I think I know that I wanted to make it complicated for herself. Do you know why? This my scientific theta here will give me a problem here. This one I can't see. I suppose 300 it as. Mm-hmm. Okay. Should I carry it to the other side? Huh? You remind me of that thing that is there. So if I come from that, pulled from that line that I wrote, e squared. Okay. So I have e squared sin theta cos theta over what? Over 2. Have you now? I'm coming. Okay, I've not added plus theta here. I know what my sin theta is now. So don't forget, I want to write cos theta now. That cos theta is equals to square root of 1 minus sin square theta. Have you now? Have you now? So where's my cos theta? Where's my sin theta? And theta is what? Okay, so I can have this one to be 1 minus y squared over a squared. At the end of it, I can have this one to give me 1 over a square root of 1 minus y squared. A squared. Have you now? Okay. So since this is it, from here I can now see that I have a squared multiplied by, where's my sin theta from there? Y over a. Have you now? Then cos theta here equals to 1 over a. Have you now? Plus. I think everything is divided by 2 now. Have you? I wish our theta is. So from here, what can happen? This a can cancel a. Have you now? So I can have y square root of a squared minus y squared over 2a. Have you now? What together? Okay. I just think I'm just done with the differentiation. But here, I was given a point here, which is what? A and 0. Everything will leave. So what is the inverse of 1? As 90. Hmm? We are closer to that, but we are not there yet. Where? Where? Here. Okay. How? How? Oh, jeez. Hmm? You want to know the answer? Where? Calm down, where? Oh, jeez. No. You see this one here now. I don't know I did a mistake. I don't know I did a mistake. This one here was supposed to multiply everything here. Let's just multiply this part alone. She gets. No, it was a square over 2. I will multiply everything here. This one cannot be. Over 2 by now. And that's missing this one here. Have you? So for me, I can have a squared Abi? Abi now? Mm-hmm. Abi now? Yeah, it's correct like that. It's correct. It's correct. Because if I put a inside here, you have what? A squared over 2 pi over 2. That's pi a squared over 4. Yo. I'll wait for you guys. I should try to know. Where did this one go? So for me to have this. Abi? And now put this boundary inside this place. What will happen if I put a square here? Yo, AY. Fast. Okay. So from here, which one are we to go to respect to first? Y. So I'll go for x first. Have integration y squared 1 plus x y squared dx. Then here I'll have x plus x squared y squared. Abi? Square. So from here. How many so far? 8. Why have you? I put everything there, I differentiate it. And you know what I was thinking? Factorize x from here. Won't you see complex my problem, sir? I'm coming. Let me give you all this one here. So we said we had 0, 1, 1, 0, x plus y dx dy. Let me pick this one first. No, dx dy. Let me pick this one first. So what do I have? X plus y. Maybe now. Dx 1 and 0. We have x squared over 2 plus what? Xy 1 and 0. 0 will cancel everything. So I have 1 over 2 plus what? Plus y. Yes. Maybe now. Then I'm now integrate this one from what? 0 to 1. And here I will have what? 1 over 2y plus y squared over 2. Yes, it's correct. It's correct. Abi now. Another one. 10 x 10 x 0 ax dy dx as 10 x 0 ax dy dz. Dx dy. So it's dx. So which one am I doing first? Doing this one with respect to y. I be now. X 0 exponential x dy. You give me what? You give me y exponential x and what? 0. Which will not give me what? X exponential x. Integrating dx. I be now. Then from here I cannot have x. I be now. So I have x exponential x minus x from 1 and 0. I have x exponential x minus 1 minus x. Okay, let me. Minus. I put 0 here. So I think the answer is minus 1. Eh? No. Answer is supposed to be 1. No. I think we made a mistake with the question, Sha. I have a kind of feeling they used the y here. Apa? Apa ti jábọ́? Okay. Hmm? Answer is 1. That means the only explanation is if and only if this one here was y. Yes, yeah. No. Yes. y0 ex dy. Abi? Then I will have had y ex. Abi now? Then I will have bounded it by what? Y and 0. And I've still had I can't no it will be dx. Then it should give me what? As exponential y as our final answer. 1 and 0. They are correct. Abi? Have you gotten to me? Then putting 1 here, that's going to be exponential 1 minus exponential 0. Which is the same thing what we got. I guess the question is wrong then. Another one. 20. Writing. 20 x squared 0 and x open bracket x squared plus y squared dx dy. You got it, have you? 20 x squared 0 x open bracket x squared plus y squared close bracket dx dy. Answer 64/3. Hmm? 64. What do we have? Call the question. 20. The x dy. So I have x here. So the closest form to integrate is what? It's to integrate y. Have you now? X squared 0. Integrating y here as s cubed plus x y squared. Have you now? The y. And for me I can now have x cubed y plus x squared. No? There's a square here now. I have x y cubed over 3. Bounded by what? 3. No. Bounded by x squared 0. We can have x 3 multiplied by x squared plus x 3. Wait. No. That's x is power 5 plus x is power 5 over 3. Have you know? So next one I have here is what? Boundary, have you? Have I integrated this one? I have not. Away. So here. Yes, now.
No, the y is inside the bracket of 3. So when you put the x squared, the bracket 3 again.
Okay.
Yeah.
So I add. Okay. I add x squared 3
Yes.
over 3, and now x5 plus x7, abi, over 3. Then integrating this, abi, x6 over 6 plus x8 over 8. Hmm? Uh, what is the boundary there? 0. 256 now, abi. Hmm? Abi? Eight, 10 is 24. 9 is 5, 12. 50. 64 over 3, abi. Hmm?
Yes, sir.
So that brings us to the end of double integral. We move again now. I've left you that I want to sleep. I continue sleeping. I continue sleeping. They don't know that sleeping is for the weak. Have you now? Sleeping is for the weak. This one now, F, X, Y, and Z. Now this one will still follow the same principle like this one will follow. But the only difference is that you're just adding one more integration. Like, I get one pencil like that. Let's look at this order. There's this one they did here. Lean. We didn't start with simple the other one. I think if we see we do now. We see we do now. Oh, look as if we have plenty here, sir. And let's start we had now. Let's start we had. Go you want to go. So the first thing is that let's try to write this thing on the board. So here it's going to give you something like ln 2 0 x 0 x plus what? Ln y. Are we together? 0. This one is what? Exponential x, exponential y, exponential z, z, dy, dx. Are we together?
Yes.
Now here I have x plus y at the same. Oh. SEO. Let me look as if this. I don't know, I feel energized, kind of. Yeah, let's continue. Thank you. Hello, Mr. Gosha, you're doing. I tell you, hello, Gio. Yeah, let's continue. Now, looking at it here, so we have already we have x plus ln y. So definitely, I cannot use a way. You can call what see what I'm saying. Let's look up, please. Since I have x plus ln y, definitely I cannot use x and I cannot use y. The only one I can use is what? Z. So I'm integrating this one here first. Then, so from here, let me just isolate this out. So I can have something like x plus ln y 0, everything here. So give me exponential x, exponential y. Although these two are constant, exponential z, dz. Then from here, you can have exponential x, exponential y, then exponential z. then everything bounded by what? X plus ln y and 0. I want to bend down. And from here, what do I have? I think now, since I'm substituting inside here alone, I'll have exponential x multiplied by exponential y. Then here you now have exponential x plus ln y minus exponential 0, right? And exponential x not exponential y. If we do this one well, then we have to pick exponential x multiplied exponential ln y minus what? 1. Have you now?
Yes.
Then here I can have exponential 2x exponential y, then dot y minus 1. Yes or no? Let's look at it too. Huh?
Yes.
Okay, good. So this is what I will now have in this method. So I now have my integration here, x0. Wow. I have x0. Then I will have everything, which is what? Y minus 1. Have you now? Exponential 2x exponential what? Y. Have you now? So now, what will I be, since I have x here, I've done z. Since I have x here, what will I be integrating with? Since I have x here, I've been integrating with respect to what? To y. So that means exponential 2x can come out to give me exponential y minus exponential y divided by x and 0. Yes or no? Then this is the y. Then I have exponential 2x. Right? Then if I integrate y exponential y, I should have y exponential y minus exponential y minus exponential y, right? Then here I have x and 0, exponential 2x. This should give me y exponential y minus 2 exponential y. Now, x and 0, exponential 2x. Then I have x exponential x minus 2 exponential x. And if I put 0 in everything, then I'll have here to be plus 2. Yes or no? No, not like that plus 2. Like if I put this one here, like this, then if I put 0 here, it should be all of this one minus. So this minus 2 give me plus 2 here. Then here I will have x exponential 3x minus 2 exponential 3x plus 2 exponential 2x. 2x, Okay, good. Then the last one, which should now be ln 2. It's not ln z, ln 2. It's not z, it's ln 2. So ln 2, so I have here to be x exponential 3x minus 2 exponential 3x plus 2 exponential 2x, then dx here, right? So let's start. If I integrate this, I have x exponential 3x minus, let's do the shortcut here. I have x10 exponential 3x 1 over 3 exponential 3x 1 over 9 exponential 3x. And I have x over 3 exponential 3x minus 1 over 9 exponential 3x. That's what that's one gives me. So I have x over 3 exponential 3x minus 1 over 9 exponential 3x minus, this will give me minus 2 over 3 exponential 3x, right? Then this will give me what? Plus, this will give me exponential 2x straight up, right? Then bounded by what? Ln 2 and 0. I feel like we should find a way to have x 3x. LCM is 9. 3x. This is minus 1, Abi? Minus 1 minus 6. As minus 1 minus 6 will give me minus 7. Abi now? And plus e2x. Then so from here, ln 2 exponential 3 ln 2. How is it that? Over 3, 7. Is 3 ln 2 plus plus then this ln 2 over 3. This will give me dot 2 over 3. 2 is part 3. Do you know why? This 3 can come here. Can come here. Come here. Minus 7 over 9 dot 2 is power 3 plus what? 2 is power 2. Wait. If I put 0 here, I think everything. Wait to. The 0 part here will make this one minus 1. And no, not only this one too will exist. That will give me plus 7 over 9 minus 1. This one here. Abi now? No, you can't just cancel out. I have 8 ln 2 over 3 minus 56 over 9 plus 4 plus 9. Away. Let's compile this. Abi now? Me. I'm going to who asked this time. I said me. Abi? Huh? No, this one's supposed to give us 19 now. I was think it was 19. This part here, every part here is correct. This piece is what is left. Hello. Hello. Okay. I was testing mic. I'm not greeting you. You see, now we done. No, if we are first time that we are done, I want to copy the assignment in mouth. Let's come. Let's move upwards back, Jerry. Let's start the let's start the tracing from here. This is what we had. Then since I was doing this with respect to Z, then I was only imputing to this place here. Then I was having EX, EY. Then I was supposed to have E in Y minus E0, right? Then this one here, E in Y minus 1, right? Wait, there's a problem here. There is. No, there is. There is. We took everything here as one. But this one here was supposed to be with this one, as this one alone separate. This one here, like was coming, this fine boy that we brought together here, we're not supposed to be together. But this one here was multiplying everything together here. So this one, it was meant to be exponential 2x plus multiplied by exponential y multiplied by y minus 1. Away. No. Away. Should we have one? Where's the calculator? See, anyone else ask me to be question this thing? Big press. And let's come again from here now. Actually, it's not painful on my part because I was just clean. I mean, okay, I've not done anything. Wait. Wait, exactly on that point. So let's move from here. Oh God. So now we're supposed to have something like this. Now x. Yeah, let's look at it together before we write again. I mean, I can't complain of because every time I do is just clean. 0 here, right? And I was supposed to have y exponent 2x exponent y minus 1. Then everything here. What were we doing it with respect to then? dy. Have you now? So in this case, exponent 2x will have been a constant. And I have x0, y exponent y minus 1. Have you now? dy. Then from here, exponent 2x should now, okay, let me erase this now. Then I know that this one will give me y exponent y minus exponent y minus y, ranging from what? X to 0. Then from here, exponent 2x. So from here, I'm having x exponent x minus exponent x minus x minus, this one will give me 0. That minus that I say will turn this one to plus 1. Then this one will go back to what? 0. So here, we can now expand with what? We can have x exponential 3x minus exponential 3x minus x exponential 2x exponential 2x. There are a lot of places you don't understand. I should know that. Okay, it's not dead. Eh? Alright, okay. So from here, I'm putting, please don't forget, I'm only putting into what? Z. So here I can have x squared y 4 over 2 minus x squared y over 2. Then it should give me 2x squared y minus x squared y over 2. Yes or no? Abi now? 4. Then the other same here cannot be 4x squared y minus x squared y over 2 to give me 3x squared y over 2. And the next one here, integration of 3x squared y over z. No, is it okay? Over 2 dy. Now this one here will now give me 0. Now I'm equating with respect to y, Abi. So let's write the answer out, which will give me 3x squared over 2 y squared over 2 and 0. So I know that if I will put 0 here, everything will leave. I can just have 3x squared over 2 dot 2. Yes? Sorry? Dot 2. Then everything here can give me what? 3x squared. Then finally, the answer here is 1. Abi? You are integrating, no? The answer is 1. It's sweet, Abi? Because it's simple. Okay. Let's increase the difficulty. Okay. We saw that. I know, we don't read it. I think that question we did. There's another version of it here. But this version looks a little bit more simpler. I don't know, I've not done it. It looks more simpler. You have 2, 1. You have 1, 0. You have 1 minus 1. X squared plus y squared plus z squared dx dy dz. Okay. Says Dexter. So now let's pick this first one and do with what? With x. So I had 1 minus 1 x squared plus y squared plus z squared dx. Dealing with only x, I will have x cubed over 3 plus x y squared, a constant, plus x z squared. Everything bounded by 1 and minus 1. So putting 1 in x here, I will have 1 over 3 plus y squared plus z squared minus, this one is minus 1 now, and minus 1 over 3 minus 1, okay, so y squared minus z squared. I can now have this one and, wait, they won't cancel out. That will be 2 over 3. This one and this one will give me plus 2y squared plus 2z squared. Okay. Then this one will be integrated with what? 1, 0 dy, which will now give me 2 over 3 y plus 2 over 3 y cubed plus 2 z squared y bounded by 1 and 0. 0 from here will give me everything, so I have 2 over 3 plus 2 over 3 plus 4 over 3 z squared. Why here? Oh, sorry. 2z squared, sorry. That's 4 over 3 plus 2z squared. Then, what is the last one? Last one, 2 and 1. So the answer here will not give me 4 over 3z plus 2 over 3z cubed. Then I am having 2, 1. So I have 4 over 3, 2 plus 2 over 3, 8 minus 4 over 3 plus 2 over 3. Away 8 over 3 plus 16 minus 6 over 3. The answer is 6. Abi?
Yes.
Hello? Hello? Sorry. So, what's the last one with you guys? Curve. Line integrals. I intentionally wanted to practice a lot of questions with this multiple integration. What's this pen? Oh, tires. The way. Hey, which one are they calculate? And now the thing is, once I end courses, don't worry, you have not started using. I am still playing. I have not started using pen. No. 47. Let's do one more. Have you now? That's what you. That voice scared me. I'm a boy, yes, sir. But I'm a boy with bone and I think by something very. We. See, your own Bible is finishing. I'm changing my ink. Should I do that one that I said looks a little bit simpler? Like that same kind of question, but a little bit simpler. Okay. That'll probably be our last trying. So A0 x0 x plus y 0 x plus y plus z dz dy dx. So let's pick the first one. X plus y is 0. So this is ex multiplied by ey multiplied by ez dz. This one going outside. So I have ex ey. Have you now? Exponential x plus y plus minus exponential 0. Right? I have ex ey open bracket ex plus y minus 1. This one can multiply this one to give you ex, calm down, ex plus ey, right? Multiplied by ex plus y minus ex plus y. This one can give me e2x plus, or better still, 2x plus 2y minus ex plus y. Then what is the next one? Next one will be x and 0, and that will be what? Dy. Abi? So moving from here, I can have e2x integral x 0 e2y dy minus ex integral x 0 ey dy. Then this one here can give me e2x. This one should give me 1 over 2 e2y x and 0 minus ex, that's ey x and 0. We have e2x was half e2x minus e0 minus ex minus e0. See here, okay. 1 over 2, thank you. So, if I have this one, I will now have E4x minus 1 over 2 E2x. Yes or no? Because E0 is 1. Then I have this. So, minus E2x plus, no? Yeah, plus EX. It comes down over 2, okay. So that's this one are the same thing. Abi? So I have E4x over 2 minus 3 over 2 E2x plus EX. Okay. Well, I think I'm just getting this part here. Okay, 3. Okay. So I have 7 now. So I think the last part is now what? A and 0. Have you? So I now have A 0 E4x over 2 minus 3 over 2 E2x plus EX dx. So now this will be 1 over 8 E4x minus 3 over 4 E2x plus EX. So here I have A and 0. Then I have 1 over 8 E4A minus 3 over 4 E2A plus EA minus 1 over 8. Abi? Plus 3 over 4 minus 1. Notice you can have E4A over 8 minus 3E2A over 4 plus EA. Compute the answer there. How will I have? That should give us minus 3 over 8. The answer should be minus 3 over 8. You. Everything is minus 3 over 8. So, doesn't look hard after all. Yep. Mathematician. So I can say that with this, if so, thank you very much.
This will actually go beyond just breaking of records, but setting. Please let's go out and let's come back and with full support, reach out to people online, send
want to break this down to its partial fractions. Now, how do we start here? Sorry, pardon. So, as usual, the first thing is I will try to check if the denominator most of the times can be what? Can be broken down. So, now let's check. Can we break the denominator down? So, let's see. So, probably we have 8 minus 3t divided by, this is 10 and this is 3. I think both of them give me 13, Abi. Okay, it would have been better if it were like this. Yeah. She answered, okay, whichever way it is. So now, so for us to work with this, that will be 15 minus 2. That's 10t squared plus 15t minus 2t minus 3 by factorizing the denominator. Abi now?
Yes, sir.
So from here, I can have 8 minus 3t divided by, what is common here? 5t. Then I can have 2t plus 3 minus 1, 2t plus 3. Are we together? Then, exactly from here, I can have what? 8 minus 3t, everything divided by 5t minus 1, and here 2t plus what? Plus 3. Okay. I think we've broken that down. Are we together? Now, so breaking this one down now, you see that this one here is a linear denominator. I'll get what I'm trying to say now. This one also is what? It's a linear denominator. So from here, what do? Next thing I just do here is what? I find its equivalence to. So I have a 5t minus 1 plus b, which is what? 2t plus what? Plus 3. Are we together? Then, so from here, by collecting like terms together, so I can have 8 minus 3t divided by 5t minus 1, then 2t plus 3 equals equivalent to a open bracket 2t plus 3, right? Plus b open bracket was 5t minus 1, then everything divided by what? 5t minus 1, and this is what? 2t plus 3. Are we together? Okay, so from here, I can now equate the numerator since the denominator are equal to each other. By equating the numerator, so what will I have? I'll have 8 minus 3t equals to what? A open bracket 2t plus 3 plus b open bracket 5t minus 1. So now here it should be better for me to think of a number, or probably think of a something that I can multiply with t, or multiply with both t, in order for me to have one of them go out. Because if I say I want to expand this one here, then start collecting like terms, then rearranging, there'll be a lot of time wasted. Now the best thing I can say is, since this is, so okay, let me leave this part here. Let me come here. Since this is 5t, I hope you know that if I multiply this answer here by 1 over 5, and I'll be left with what? 1. And 1 minus 1 will give me what? 0. I guess one parent say like that. So from here I can say that let t is equal to what? 1 over 5. And from here I can have 8 minus 3 open bracket 1 over 5 equals to a open bracket 2 1 over 5. Are we together? Plus 3, then here plus b. What do I have here? This is 5 times 1 over 5 minus 1. Are we together? Then this one will give me 8 minus 3 over 5, which is equals to a, and this is what? 2 over 5 plus 3, and everything here plus b. This is what? 1 minus 1. So from here, the LCM here is what? The LCM here is what? Is 5. What do I have here? I have 4t minus 3 equals to, the LCM here 2 is what? 5. So I have 2 plus what? 15a. Yes or no?
Yes, sir.
And so from here, 40 minus 3 will give me what? 37 over 5 equals to, this one is a equals to 17 over 5. So I think by multiplying both sides by 5 and dividing by 17, you can have that a is equals to 37 over 17. Yes or no? Okay, good. I've gotten my A. Now the next thing for me to do is what is to get my B. And how do I get my B? The same way, but this time I'm not expanding. So let's think of a number. Now, what number can I use to multiply this here? That can give me, first of all, that can give me a number that can match with this 3 that is here. What number do you think it can be? So let's say that if t is 3 over 2 minus 3 over 2, I mean no, minus 3 over 2 will work. So I can answer that let t equals to minus 3 over what? Minus 3 over 2. Are we together? Then from there, I will now have a minus 3, okay, minus 3 over 2. Are we together? Equals to a open bracket 2 times minus 3 over 2 plus 3, then plus what? B, and what do I have here? 5 times minus 3 over 2 minus 1. Are we together? And everything here will give me what? 8 plus 9 divided by 2, which is the same thing as a everything here minus 3 plus 3, right? Plus b, which is minus 15 minus 1, right? Okay, minus 15 over 2. Okay, from here just same here is 1, so I have 16 plus 9 over 2 equals to, so I can have, this one is 1, so I can have b open bracket minus 15 minus 2 over 2, and this is giving me, what is this now? 25 over 2 equals to minus 17 over 2b. Doing the same thing I did to this part here, multiplying both sides by 2 and dividing by minus 17. I can see that b here is equals to what? Minus 25 over what? 17. Are we together, please? And since my b is equals to this, and the next thing I can do here is that I've gotten a and I've gotten b, so try as much as possible to put them inside here. You can now say that therefore I have 8 minus 3t divided by 5t minus 1, 2t plus 3. Are we together? And then this is equivalent to, let me write this a like this, a multiplied by 1 over 5t minus 1. Are we together? Plus b open brackets, what do I have here? 1 over 2t plus what? Plus 3. Are you getting it? So from here, what is my a? My a is what? 37 over 17, 1 over 5t minus 1. Are we together? And minus 25 over 17, 1 over 2t plus what? Plus 3. Are we together? I think with this I have gotten to do what? The end of this part. I'll get it, please. Now let's write. So I think all the partial fractions under that section will solve everything. Prepare ourselves for partial fractions. And the next topic we'll be looking at will be I think that's binomial expansion. Abi? Yeah, binomial expansion for 3. Alright. We'll move. Writing, but as we're writing to, let's try as much as well to write very, very fast. You understand?
Yes, sir.
So let's write fast. So we're writing fast. We go a long way. How have you all slept well last night? Yeah. Why didn't you sleep? I didn't you sleep? Sleeping now? I think together. Thank you. as soon as you're done, just let me know so that we'll continue. You're done, right? Good. Okay, so okay, we're done with the first part. Let's look at this other partial fraction, which is w squared plus 7w everything divided by w plus 2. Now we go right here, w minus 1, and here I have w minus 4. So one thing you notice here is that already this one has been linearized, so you can just arrange it so that a equals to w minus 1 plus b equals to x plus 3, w minus 4, w minus 1, c is equals to what? w plus what? Plus 2. Yes or no?
Yes, sir.
Then from here we have w squared plus 7w divided by w plus 2, w minus 1, w minus 4, everything here. Now what will be the LCM 2 here? W minus 4, 1, w plus 2. Yes or no? So from here, the next thing we do with is that, so if I deduct from here with these two, right, I can see that here I have a over bracket was w minus 1, w plus 2 altogether, plus b, which is what? W minus 4, w plus 2, and plus c equals to w minus 4, w minus 1 altogether. So now we see that the denominator is equal, so I can make the numerator to equal. Yes or no? By saying here I have w squared plus 7w is equal to what? A open bracket w minus 1, w plus 2 altogether, plus b, w minus 4, w plus 2 altogether, plus c, w minus 4, w minus 1 altogether. So from this one here, we want to start making some ones equal to 0. As I said, it should be stressful if we start opening the bracket altogether. Now the first thing, I think it is easier for me to remove 1. Let's say that let w equals to 1. What do I have here? I have w squared plus what? 7w equals to here a 1 minus 1. No, 1 plus 2 altogether, plus b, what do I have? 1 minus 4, 1 plus 2, plus c, 1 minus 4, 1 minus 1. So, oh, I've not put w here. Let me put w here. So I have 1 squared altogether.
Yes, sir.
1 plus 7 will give me what? 8. And here I have a 0 times 3, right? I mean, no, 1 minus 1 is 0. And plus b minus 3 times 3, are we together? Plus c minus 3 times 0. I think I can have 8 is equals to minus 9 b. Yes or no? And b will give us minus 8 over what? Over 9. Do you understand? Okay. I've gotten b. Then also let w equals to 4. So if w is equals to 4, what do I have? I have 4 squared plus 7 open bracket 4 altogether was what? A open bracket 4 minus 1, 4 plus 2, right? Plus b open bracket 4 minus 4, 4 plus 2, and plus c W, sorry, 4 minus 4, 4 minus 1, then 4 squared is what? 16. 16 plus 28, that's 44. Abi? Equals to A open bracket 3 times 6 is what? 18. And all together plus B here 0, 6 plus C 0, 3. All together from here. Now 44 equals to what? 18A, and A equals to what? 44 over 18. If I divide both side by 2, what do I have? 9. Together? I'll get in this piece. Alright, so the next one here is next one here after this is let W equals to, which have we not used? I think it's 2 that we have not used, Abby. Let W equals to minus 2. So what do I have? Minus 2 plus 7 open bracket minus 2, Abby. Equals to A, I've been there before, where minus 2 minus 1 minus 2 plus 2, but makes me minus 2 minus 4 minus 2 plus 2. How together? M plus C. Now minus 2 minus 4 minus 2 minus 1. At the end of God's grace, minus 2 all squared will give me what? 4 minus what? 14 equals to A open bracket. What do I have here? Minus 3, 0, right? Plus B, what do I have here? Minus 6, 0, plus C, what do I have here? Minus 6, minus 3. How's together? So from here, 4 minus 14 will give me what? Minus 10 equals to what? Minus 18C, plus 18C, and 18C equals to minus 10 on that page. I'll take it out. And from here, what do I have? I have 9 over 9. Not 9. Minus 5 over what? Over 9. Yes or no?
Yes, sir.
Good. That's equals to my what? That equals to my C. So I've gotten A, I've gotten B, and I've what? Gotten C. So therefore I can now say that. Let me come to this side and come out right, combine everything. How can I say that? Recall that. What's first recall? Recall that W squared plus 7W equals to W plus 2, W minus 1, W minus 4. Everything is equal to, what is my A? Let me write it as A open bracket 1 over W minus 4, right? Plus B open bracket 1 over what? W minus 1, plus C open bracket 1 over what? W plus 2. From here I have, what is my A? My A is what? My A is 22 over 9 and 1 minus 4. What is B? Minus 8 over 9, 1 over W minus 1, plus C plus minus 5, minus 5 over 9, open bracket 1 over W plus what? Plus 2. That's a final answer. Do you understand? Okay. Now is your time to write. Yeah, I for you guys to write. Are we done? Are we done? Okay, so that's the writing. Are we done? Right. Next one we have 8 equals 3. 8 divided by 3x3 7x squared plus 4 equals to, we don't know. Now question is, can we factorize this one? I don't know, but let's find out. I have 3 here. Okay, x minus 1 is a factor. Have you now? Can you show me the x minus 1 is a factor? Huh? X minus 1 is a factor. Yes. So let's see. Have I taught the polynomial division? Yes, I did. I have 8x cubed plus what? 7x4 plus 4. And what's the factor that you can create here? X minus what? 1. Have you now? From here I have 7x squared. Okay. By this one I have 7s squared. No? First thing, 3x squared. Then this will be 3x cubed minus 3x squared. So if I subtract both sides, what do I have here? 9x squared plus 4. X in 10x squared will give me what? Plus 10x. Have we? I put this one inside. I have what? 10x squared minus 10. Zero. What's my factor? X minus 1. X minus 1 should be a factor now. Three times minus 1 is what? So what is your reduce to this one now? X minus 1 is the best solution for us to use. Yeah, I'm open now. What do you think we do? Or should we see the questioner's problem? Hmm? 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 X plus 1. If I put 1, no, if I put 1, you can't have anything cancelled out. But if I put minus 1 here, oh, it shouldn't be x minus 1, it should be what? X plus 1. Then this one will be 4x squared, have we? Plus 4. Then this one will be 10, this will be what? Plus 4, right? I mean, now this is what? 4x squared plus 4. Okay. That means I can say that 3x cubed. Okay, that's equals to 8 over 3x squared plus 4x plus 1 and a good job. You want to write that down? Like the polynomial, I should clean it. So from here, this one is 8 square plus 4 8 square what is the last one? Okay, I think that's all. So from here I can factorize this one, but this one is not a factor, so I can have this as a over x plus 1 plus what, bx plus c, 3x squared plus what, 4. Do you understand? Do you understand? Whenever you have a fraction, what I call this now, a function that you cannot formulate or you cannot solve to get x, you use bx plus c on top of it. For example, now I cannot solve 3x squared plus 4 without having a minus answer. Abi, that's why. So from here, I cross multiply, so I can have 8 is equals to 8 divided by x plus 4 1 plus y. So this is my ampere. My a, I don't know the person. Minus 3x squared plus 4 plus bx c x plus 1 x plus 1 x squared plus 4. So from here you can have 8 equals to a 3x plus 4 plus b x squared plus bx cx plus c. Okay. So here, sorry. 8 x squared. Okay, let's call that comes together. Plus 3bx squared plus. Now squared plus bx plus cx plus c. A plus 4a, okay. And from here I have x squared 3a plus b. Have you? Oh, president of. And I think that's all. B plus C plus 4A. Yes or no? So let me see comparing coefficients. So there's no x squared here, so I can say that 3a plus b plus 2 next one here, b thousand then that's fine. Then I know that c plus 4 is equals to what? 0. Maybe a equals to minus b, and this c equals to minus 4a minus 3. Where's my a then? A x squared. Are we together, please? Have you now? And where is my here? I think we got here first. So this all for here first. Hey. Okay. From x, b plus c equals what? B plus c equals 0. Have you? 0 I've divided here as 4 now. This is c. Have you? I have minus 4 over 4. Abi? Equals to 0. Abi? Then I can say that c equals to minus 4ax. B plus my c is minus 4a minus 4a. How is it now, please?
Yes, sir.
Okay. I've gotten this one here. Okay, start from comparing coefficient. See here, this one does not have squared on this side. That's why this one is 0. X b plus c. This one does not have x on this side. 0. And that's supposed to be equal to 8 self. C plus 4 is a constant, yes. Then so I can say that here your 8, I getting it, 8 c plus 4a equals to 8. I can say that c is equals to 8 minus what? 4a. Abi? Let's do that here. So I can have b plus, what is c now? 8 minus 4a equals to 0. Abi now? Therefore, I can now take this on to the other side, so I can have b minus 4a equals what? Minus 8. Yes or no? Then for the last part here, don't forget that I said that a equals to minus b. I can have b minus 4 into bracket minus b minus b. Abi now? This is okay. Over 3 minus 8. And so from here I have b plus what? 4 over 3b equals to what? 8. That's not even okay, let's say minus 8. Then if I multiply it by 3, it will be plus 4b equals to minus 24. 7b equals to what? 24, and b equals to 24 over 7. And if I've gotten b, don't forget that a is equal to minus b, so a is equal to minus 24 over 7. A is equal to what? A is 24 over 7. Yes or no? Now b over 3. Am I forgetting that minus b over 3 now? And that's equals to 1 over 3 minus 24 over 7. 3 cancel 3. Minus is, yes, this is minus now. Okay, minus in front, the minus solution. And that will give us plus 8 over 7. I think that's balanced. I've gotten A, I've gotten B. Which means C. What is C here? C, eh? Okay, I can also say B equals what? Minus C. Or better still, C is equals to what? Minus B. What is my C? Minus, what is B? What did I get for B? 24 over 7. And your answer is C is equals to 24 over 7. So from here, so I can answer that 8 over 3x cubed plus 7x squared plus 4. Because what is my A? 8 over 7 open bracket 1 over x plus 1 all together plus what is B? Minus 24 over 7 x, can you see? 24 over 7 kilogram. 3 plus 4. Then from here you must write it very well as 8 over 3x cubed plus 7x squared plus 4. 8 over 7 how together? 1 over x plus 1 minus 27 over x minus 1 3x squared plus 4. I mean, now you can use this as answer. Do you want? Talk now, the plus. Huh? Okay, the sign in between them. And I've removed this minus. If I remove the minus will affect everything I say. So, what's good? Okay. I'm done. Okay. So look at next one. So better fraction, but it's a little bit different in the sense that you have a repeated linear. You have a repeated linear here, and in this case, this is equal to a over z plus 1 plus b over z minus 5 plus c over z minus 5 squared. Alright? Let's compare. Have you now? So tell you vacuum by vacuum. Z minus 5 squared. Yes or no? Plus C. Have you now? You don't have anything. Squared. Okay, yeah, Z plus 1. Thank you. Z plus 1. Right. Where? And I know. Okay, here. Yes, but the thing that is here is that this one is linear. You have to move from 1 first to squared. That's how this one works. If it is like single, like separately, like the one like, okay, I don't think I did anyone like that. Okay. I the one we did previously. I was just 1. I just had a over plus b over. But now this one that is squared, even if it is cube, if it were to be cube, it starts from what? Ordinary 1, then move on to 2, then move on to 3. Do you understand? Okay, good. So I think from here I can answer that 3z squared plus 1 is equals to a here z minus 5 squared. Have you now? Plus b z minus 5. You know, z plus 1 plus c z plus 1. Analyze that. Let equals to 5. So what do I have here? 5 squared plus 1. And here, so f minus 5. So plus b minus 5. This one 5 plus 1 plus c 5 plus 1. 3 times 25 26. Please interpret here plus 6 c. So 6 plus minus something. How to get that? So let z equals to minus 1. Abi? Abi? Abi no? Abi? This is 3 plus 1, which is 4. 1 minus 5 is 4. Minus 4. That's 16. Equals to 1 over 4. Put it together. It's 38. 3 times 25, 75, 76. 76 divided by 6 is what? Hmm? I've gotten everything. Abi? You mean B? How can I get B? B has both of them. Abi now? B has both of them. Hmm? No. B has Z minus 5 and Z plus 1. I cannot use elimination method. Oh, I think I can have, the only thing I can do is what? Expand. Away. Yeah. A Z squared minus NZ Z5 plus B Z squared plus Z minus 5Z minus 5. How together? We got CZ plus C. How together? AZ square then AJ 25A BZ square minus 4BZ minus 5B Shilaya plus C. Are we now? What's next? Let that come together. Abi? Where did I see G? Eh? Why hide something that doesn't exist like this? Eh? At least I don't know that. Wait. Wait. There should be a 4 here now. Eh?
Yes, yes.
Wait. Oh, do you know what? Wait. Eh? Start from here. It's correct here, Abi? Next one. I think this one too is correct. Abi now? Use B to open this one. BZ squared, BZ minus 5Z minus B. Correct? Good. This one too. BZ2 is correct, Abi? 3Z squared plus 1. Let's write them together. Z squared plus BZ squared. Then any EZ again. Minus 10AZ plus this one and this one. Minus 4BZ plus CZ. Plus 5A plus C. What do I say comparing? Equals to 3. Abi now? 5K. Wait, where? Okay. Z, for the ordinary Z. That for ordinary Z. Minus 10A, Abi. Minus 4B, Abi. Plus C equals to what? 0. Abi. Then for the last one, which is what? 25A plus C minus 5B equals to 1. What else? I mean, what do I know there? It's only here I know. What do I know? I know A and C. I B now. What am I looking for? I'm looking for B. I know A and C. I'm looking for B. Come on, attack. I know A and C. I'm looking for B now. Attack it here. Where is your A? And B equals to 3. I'll continue.
Yes, sir. Yes.
Who said no?
Yes.
Can we start?
Yes, sir.
So what is next? What next am I doing? So let's combine everything together. Abi now? How can I say that? Abi? How is it that? Eh? Hmm? How is A? Abi? So what would this format be? Eh? Mm-hmm. Hmm? Mm-hmm. Abi now? How is it that? Hmm? Hmm. Mm-hmm. Should I open the bracket? Then let us open it now. Hmm? Yes, Aramo. Why you guys not talking again? You cannot see it. Hey, wait. Are you talking? Don't leave me alone. No, it's not that one I want. Be here physically and we'll be here with you on the board too. Don't leave me alone, I beg. You do a correct addition. So from here, what I do? Let me eliminate. So I can see that 0 equals to 6. Yeah? And can we continue, please? Are you doing written exam? Is it written? It's not written now. If you say it was, you are correct. If you say it was written, then I probably might have to change the BZ. Wait, okay. What about? Why didn't you talk about this one? Because where is it? Wait a minute. The first part of I think here we use okay, even if we use X here, so it doesn't really matter. Since I used to say it was written and see when you're just talking about it now. Continue from here, Jade. So what? 6 squared plus 2, 6 plus 3, 6x plus 4. Abi now. Right? Okay. Abi? Your 6 plus 36 plus 12 is what? 36 plus 12 is what? 48 plus 3 is what? I think this one will go now. 36 plus 4. 36 plus 4, 40. Abi now. Abi? The next one I have to do is what? Is expand. Abi? I'm going to expand on that part. Yeah, will you call it for me? So, yeah. It's not. It's not 2C now. It's Z.
That's it.
Have you now? Have I gotten E? Have I gotten E? What's the problem? Two equals to 1 minus 51/40 minus 11/40. Which that's 66/40 now. I can say that here. Let's say me 80 and 66/40. Huh? What's the question? Z minus. I can break it down if you want to. I'll continue like that.
Yes.
Are we sure?
Yes.
Which printing? Okay, I see writing. Yeah, write fast, please. I see you. Yeah, I'm waiting for you then. Determine one. Okay, so it's even you that you're raising the banner last night. Was it you? Banner, banner like this. Okay, so it's you. You know me. You're raising banner. I tell him not to stop once I finish. You don't know, I don't know. I'm done writing, please. I'm waiting for us to finish writing now. Because I want to call some few things on banana expansion, then continue. Can we start now? Okay. Now binomial expansion. Let's oh dear. Okay, binomial expansion is the branch of mathematics. Binomial expansion is a branch of mathematics. Lefty, how are you? I'm not a broom bear. I lost a color of my. I think both. Maybe, because I prove as I said that binomial expansion is a branch of mathematics that deals with expansion of terms. That is with expansion of terms. Expansion of terms. Okay, full stop. Okay. Let's talk about that. What do you mean by that is that there are some scenarios that your terms that you might be given might be so large that you won't be able to expand manually. For example, if you want to expand 2x plus y raised to the power 15, although you will still expand it too. But I'm just telling that if you want to expand something manually, or if you want to expand something that is big, the things you use to expand it is your binomial expansion. Another example, probably want to expand, or you want to do the coefficient of, you know what coefficients are? Do you know what coefficients are? Coefficients are the numbers in front of your variables. Let's say in a particular expansion, you want to know the coefficient of that term in that expansion in a meeting. Maybe you don't go to the meeting, you want to know how many people went to the meeting. And you get what I'm trying to like that. So there's a need for what? Binomial expansion. Are you getting me? There are two ways to expand. You can write that. There are two ways to binomial expansion. There are two ways to binomial expansion. There are two ways to binomial expansion. Number one, Pascal triangle. Number one, Pascal triangle. Number two, combinatorics. Number two, combinatorics. Combinatorics. How would you get that? Combinatorics. And now once you use, first of all, I'll teach you how to construct Pascal triangle. Let's talk about binomial triangle. Pascal triangle. I don't know if I've seen this thing before. Are we done writing? Where? It's then. Yeah, what am I sleeping now? I'm sleeping. I'm sleeping. I'm sleeping. So this is Pascal triangle, and the Pascal triangle is used in expansion. You want to expand terms. Maybe probably they give you to expand x plus y equals to 7. And you know that if you want to expand x plus y equals to 7, It's going to be a very, very difficult thing to start opening the bracket. X plus. You get what I'm trying to say like that now. In case I'm also you now that's a way to now I can just take this one as a way to make expansion of bracket or expansion of terms very, very easy. Are we together? That's about the numeric expansion. However, when this is numeric expansion. We've talked about what it's used for. We know. You said that we want to use to expand terms. And whatever I've written here, that n is telling you that number of times each of those lines can expand. Now, look for example, if you want to expand I want to expand this. And I normally want to expand what we have done. So I open the brackets. I mean now 2 2. And after we open 2 2, now open 3 3 again. Before now open, I think before you get to the final answer. But here you can just compute it. Now all this number that is here, this particular triangle, are the number of terms that will be in front of your expansion when you start expanding. You got a principle like that. I will explain to you that the numbers that will be in front when you start expanding are all together. So from here now, let's expand. Another thing is that in this binomial expansion, there's order of increase and decrease. Whatever is here, whatever that starts this your term here, is always decreasing. Whatever that starts this time here is always what? Increasing, decrease, increase. I get one apprentice like that. And at any point in time, at any point in time, the sum of their power must be equal to the power they are coming from. You got an apprentice like that. So let's start. Number 1, x is power 7. This is 7. Let's start. X is power 7. Maybe now. X is power 7 here. I told you that this one will reduce. And if this one reduced by 1, this one will increase by 1. Then plus. What's the next time after that one? 7x6 into this your y plus drop. I guess what I'm saying, please. I've been now. Please, I get me, please. 1 7 6 1 21 y. It should be x5 y squared plus 35 x4 y cubed plus 35 x cube y 4 plus 5 x is a 1 y 3 7
That's supposed to be x raised to power 2. No, that's an x to power 2. Y raised to power 5. X to power 1.
Okay, this I should look like minimal expansion. Please do you understand? So let's say I want to do this work. 4. This is my everything is my x, everything is what? It's my y. I get it. Everything is my x, everything is my y. So I'll go and look for 4, which is 4. So that starts with 2x 4 plus 4. I get it. 4 times 2x is to power 3, abi 3y, abi now. Plus next time is what? So 6 times 2x all squared 3y second night. How together? Plus 4 2 the night class and 3y 5. Abi now. Plus 3y. I'll get my pencil there. 4 3 2 1 0. I get my pencil like that. This is binomial expansion of terms. From here, if I want to break this one down now, 2 is power 4 is what? 16x4 plus here. I have 4 times 8 is what? 32. 4 times 8 is 32. 32 times y. Mm-hmm. 6 times 4, 24. 24 times 9. Eight times. Mm-hmm. It's 26 again. Again. Calm down. This one is here. The theory of this one is 96. This one is what? 216. The time now this one is what? 216, Abi? Abi? So you get, please. From extent, have you? This is it. Whenever I want to expand, this first time here, take your highest power here, follow these coefficients of expansion. So 2x 4 plus 4, next expansion, times, now this one is 4, as this one will now start to decrease, 2x, then this one will start to increase by 1, then this one to have 6 here, this 2x, decrease, increase, 4 from manual, going to decrease, then for the last time here, she gets, let's look at another expansion. Okay, let's look at another expansion. So what to start? This one. This is about 6. What's the first time here? 1 times s is power 6, I now. Plus next time after 1 is what? 6, I now. Times s is power 5. Then this time here, 2y is power 1, Abi. Plus what next time again? 15, Abi. S is power 4. Then 2y squared. I was get out. And plus the next time is what? 20. S is power what? 2y is power 3. But this time here, 15. Abi. S is power 2. 2y is power what? 4. Plus 6. X 2y is power what? Plus 2y is power what? 6. Do you understand? Amen. Thank you. So we want to expand this one now. Let's expand. Six times 5 is what? Abi? 15 times 4. Yeah.
No.
15 times 16. Yeah, now. Abi?
192y.
What does that one look like? Ah, you must master it. Eh? I must keep doing it. See, my body responds very well. My body is not responding yet. So once my body starts to respond very, very, very well, we'll still be doing it. Now, this one. I'll take it down. So, this one here. So that would be 2x to the power 5 plus 5 2x to the power 4 minus 3y plus 10 2x to the power 3 plus 3y 2 and plus 10 2x to the power what? 2 1 plus 3 divided this should give us